Hey, good morning, everyone. Uh, Kaibalya, who else from your team has joined?
Yeah, hi there. Good morning. Yeah, both of them are joining right now. Let's give them a couple of minutes. Right now, it's just me.
Okay, while we wait, so we'll start the session at 10:05. I think the team Nyaya has joined. I see Kaivalya, Senthil, and Aditya here.
Hi, sir. Hi. Good morning.
Hey everyone. Mati din ang sakit. Ada screenshot ko ang sakit. Play tatlo.
अभी तो आधार कार्ड पड़े ना विना अभी तो आधार कार्ड आधार नंबर
We are slowly getting into the details. It's already 10 and I see people signing up. Just wait for 1 or 2 minutes and then we'll start. I would request all participants to mute their mics. Team Nyaya, one suggestion, it might be good to share your repo link upfront. So maybe you can post the GitHub public repo link in the chat. We'll reuse it during the sessions. Thanks, Kaivalya. Yeah, so let me just, okay, without much delay, let me start today's session. Good morning, everyone. Welcome to the second session on the GenAI workshop that we are doing as part of NPTEL Plus. Just to make sure that the context and the expectations are matching, let me just restart. So we had feedback from a lot of you in the last session that you wanted to have more hands-on, whereas the sessions are more geared towards identification of problem statement, how the entire process happens. So a couple of things that we have done from our side is, so I believe all of you have received the GitHub repo and the slide deck from the previous session. If not, I'll just paste that in the chat in a minute. So the previous session, so session 1, we had discussed a health app, which was built by Bharat Mahindra, who is a student at the IIT MBS program. He's also a working professional working on products, AI-related products. So his app is available at this GitHub URL. This is the GitHub URL that where you can see the app. And there is a docs folder in this GitHub where he has actually put the session slides that he had used for that particular app creation, and the product design, the PRD equivalent documentation that he has used for creating that particular app. So in today's session, what we will go through is another app, which is it's called Nyay Agent. So this is session 2. We are upfront sharing the GitHub repo so that you can actually go through the code base. So for all those people who are familiar with coding, they can go through the code base. The others can basically get an understanding of what happens in a okay, I think I'm posting it into a specific. So let me. Okay. Okay. So 1 second. I think I have posted the one to WebMTech user. Let me try to chat. Do I change? Meeting. Yeah, sorry. I think the chat went only to WebMTech, the host of the session. So let me just copy paste the message once more. So session 1, I hope all of you are able to see the chat message that was put. So this is the GitHub repo that was used. The session recordings for the same is shared via Google Drive. If you have not gotten the link, then 1 second, let me just paste it over here. So after every session, please feel free to fork the repo. There is a contribution guidelines that Bharat has put up. So people who want to take it up, maintain and other things, you can feel free to contact Bharat. His details and his contact details and others are provided in the GitHub repo itself. Okay. So for what happens typically for all NPTEL Plus workshop sessions, all the sessions are recorded, and at the end of the session, I mean, typically a day or two later, this entire recording gets processed and it gets uploaded into a Google Drive. And that Google Drive link is shared with everyone. So the session 1 recording is accessible in the Google Drive link that I've shared. For session 2, we will be talking about Nyay Agent. So this is more on to legal querying. I mean, so what happens when you are stuck and you want to really understand the legal precedents and the associated things associated with it, associated with the problem that you are facing. This entire session, this entire app was created by a group of 3 members, Kaivalya Deshpande, Aditya Dhaval, and Senthil Kumar Natarajan. All 3 of them are here today. So they will walk you through the entire system. A couple of things that we have tried to improve in the current session is, at least we have tried to give you the motivation behind the development and follow it up with a slightly a block level view of the different parts of the app. And once the app is done, then there will be a live demonstration along with a little bit of walkthrough of the code base. Okay, so they have used a multi-agentic approach. So in the earlier one, you have seen Bharat using a standard fast API based backend, simple Llamaverse, or a simple RAG that he has created. He used a simple, I think it was Llamaverse that he has used for parsing the entire thing. So he has used basic code for developing the entire application set. And then he has UI. He has invested a lot of time in identifying the use cases, having the UI cater to that particular aspect, and then used AI for the polishing of the recommendations and synthesis of it. So that's what you have seen in the last application. In today's case, you will see a different set of tooling, LangGraph, multi-agentic. So these are like jargons that keep coming in the AI development arena. But I'll have these 3 people explain the Nyaya agent to you. At any point of time, if you have questions, please raise your hand. To the best of our ability, what we want to have is the entire demonstration session we want to conduct in one shot with minimal disruptions. So I request you to, so if you have questions, since there are 3 of them, one suggestion that I have is please post your questions on the chat. Okay, and one or the other will respond to it. May not be real time, but at least they will look at the chat and then appropriately respond. Some of the responses will already be there in the presentation, so they will hold off that. But towards the end of the presentations, we can have a more direct Q&A. We'll also break in between, smaller breaks in between for a smaller set of Q&As. Kaivalya and team, that's okay, right?
Yes, sir.
Yeah.
Hello, am I audible?
Oh, yes, sir.
Okay, so the idea is rather than having questions, multiple questions in between, let's have dedicated slots for Q&A in between the session. So after maybe the tech stack, we will come up with the first set of questions, take up the first set of questions, and then followed by the first demonstration and then the other set of questions. And then finally the big Q&A. I hope that this model works for you guys, right? Okay. So then without much ado, let me just formally introduce, yeah, so I've already done the introduction of Kaivalya, Aditya, and Senthil. I would request them to start their presentation, and in between we'll stop for questions and answers. Yeah, Kaivalya and team, you can take over from here.
Sir, Kaivalya has audio issues. He is trying to reconnect. Give us a moment while he is trying to connect.
I think Jay Krishna, you are on mute. I think you are trying to speak, but you are on
Oh,
mute.
sorry. So I was asking Senthil, Kaivalya, and Aditya to start the presentation for the Nyay agent. Are you guys able to share your screen?
Sir, actually, Kaivalya has some audio issues. He's trying to resolve it. Give us a moment. So,
Okay.
Hello. Hello. I'm
yeah,
audible.
he's back. Yes.
Yeah.
Yes.
Aditya, are you?
Kaivalya.
Kaivalya.
uh,
Hello.
Yeah. Am I audible?
Yeah,
Yes, you are audible to me. What about others? Are others able to hear Kaivalya?
But voice is very low, Jay Krishna. Kaivalya's voice.
Okay. Kaivalya, you may want to put the mic closer to.
Yeah, sure. Is it better now?
Yeah.
Yes.
Okay. Let me share my screen. I'll share the paper. Do let me know.
yeah, it is. This will help.
Okay, so let's start with the Nyay agent. Hello, everyone. I'm Kaivalya Deshpande, and me and my team we built this Nyay agent, which was specifically the aim of this was to uh, reduce our need for our basically increase our understanding about any legal cases, legal issues that we are facing, and reduce our anxiety. I'll say, like, this is not specifically, we're not aiming to replace any lawyers or issues. Like, we can't go directly ask everything to AI and then take this to court. So this is just for a second of it. But that was our aim that we wanted to cover. Now, what is the problem specifically? Now, the main issue that we wanted to tackle with the creating this Nyaya agent was that essentially, I'll say that since I'll assume that most of us are from engineering or some tech related background, so not all of us has a very in-depth knowledge about whatever the legal cases are. Like, let's say a very simple scenario. Let's say I'm living on rent somewhere. Now, when I am shifting, this guy refusing to return my deposit, or this guy is intentionally, some landlord is intentionally increasing the rent multiple times a year, which is really getting unaffordable to me. And all of these things now, this is I'm talking like specifically from my perspective. Some of these things I've faced myself, and so I'm very illiterate when it comes to the legal issues and how to like tackle these scenarios. So I just wanted some space where instead of me wasting multiple hours a day just frantically Googling everything, hey, can I do this? What is this situation and all? I wanted one area, one agent that will help me to get a better understanding and uh, at least prepare me a little bit so that when I'm wishing I want to take further actions, I'm a bit better prepared. And what a lot of issues that I faced is like when I'm trying to check online is, first of all, as I mentioned, it takes multiple hours, a lot of time, and also many of the things like I am skipping a couple of names, but when we check out some online spaces where we can get some consultations, these are subscription gated, quite expensive for one singular session and all. So that also did not feel like a very viable solution to me. So that is why we decided to come up with the Nyaya agent. So, what exactly is Nyaya agent, and how is this particularly better than our regular chat on with ChatGPT or Gemini? So, I'll say one thing. I think this one drawback of AI, it is very popular among the like anyone who has dabbled into even a little bit, he will know that hey, one of the very common issues with AI is that it hallucinates. You might have heard this keyword a lot during this, and while that is with every new release of the agent, every new version of the agent, it is going down. But it is still a very known issue with it. And what happens is that essentially, if there is some knowledge gap with the AI, even many times it happens that even AI doesn't know that it does not know that part. It just fills in some random data and then uses that data as factual knowledge, and then will it will present to you that hey, this is the real truth. And now many of the times when you are going through this, you don't even question like, okay, if he's saying with such confidence, then it might be true. And what that does is, at least in the let's say that I'm writing a code, I asked it for a code, it gives me some bunch of lines, and when it is wrong, when it hallucinates, when I run it, okay, worst it happens is it will fail, right? But the three major fields like legal, financial, and medical, there it is very essential that we do not make these kinds of mistakes. Like, right? So we cannot ask the any AI like I am having a headache and what medicines I should take, and it prescribes me a medicine while hallucinating. I take the medicine and it has a lot of negative effects. Now, who am I going to blame? I cannot directly ask OpenAI that, hey, now you're responsible for this. No, they're not. So this kind of situation, this kind of scenario really makes people hesitant to use AI for legal advice. I'm not sure if you're aware. Let me tell you a bit a recent news. There is a game company which recently got into a financial no, a legal battle, and the CEO of that company, he used AI to draft a legal draft and used that in court, and it failed very miserably. Okay, so I believe they lost that battle because the judge directly said, "Hey, this is completely bogus. You cannot use this kind of draft. Half of the things are false in that. I don't know which laws it is citing." Uh, and they lost, I think, a multi-million dollar lawsuit because of this. So that these kinds of things, these kinds of stories, when you listen, then you say, hey, I would rather not know this and go to a lawyer and all, and which is recommended honestly. Like when you have health issue, it is recommended to go to the doctor. When you're having legal issues, it's recommended to go to the lawyer. But what we are trying to focus here is that essentially you have a second opinion when you're going to visit the lawyer. Then you have some idea about what kind of issues you're facing, what kind of things you need to focus on, and all. So let's if you can see the look at the diagram, let's focus a little bit of the basic structure of Nyaya agent. So essentially we have built this project mostly like a chatting system. Right, a typical chatting system where me as a user, I can go on the website and chat up with Nyaya agent that, hey, let's say that I want to do XYZ thing. What things should I be aware of? So it will take the data, it will and then give me a response. Now again, if I circle back to the previous question, how exactly do we reduce the risk of hallucination? Now for hallucination, I'm sure you might have heard about the RAG, about RAG. So what how RAG helps us is that I can ask my agent LLM to only stick to the data that I have stored in a RAG. Right. So when I take a bunch of data from a bunch of legal documents, which I know are factually correct, I parse them and I store them in a RAG, and then I ask my agent to, hey, uh, I am asking you to explicitly use only the data you receive from RAG, nothing else. And this what this does is it greatly reduces the risk of hallucination, and we have a little bit of trust in that hey, if we are getting this data, then this must be correct. And not saying that it still completely eliminates the risk of hallucination, and that's why we have multiple other guardrails set up already, which we will discuss further down the line. But for now, let's move to the rough flow. So this the UI we have built it on Streamlits. A simple flow would how a simple flow would work is that me as a user, I will go on the Streamlit UI and enter my query that hey, I want this XYZ, and then this query will be shared with my agent. Now I have not one, I have three agents in the backend working, three different LLMs. But we will also discuss about them later. So right now, what it does is my agents, they will fetch whatever relevant data it already has from the RAG, and then they will do a compliance check on it, that whether the fetch data is relevant or not, and accordingly they will create a response for me and also create a memo for me. Now, a simple response is I will get a response as a chat where I can see, hey, you should be aware of this kind of situation. Like when you are driving on the road, you should be careful about wearing a helmet, because apart from our health, it is also illegal to ride without a helmet and all. So something like that. And also it will give me the citations, which is one of the major concerns for us. Like, how do we know that the AI is returning true data? So that's why we are also fetching the citations from us. Like, hey, whatever data that I am collecting, whatever response that I'm giving you, these are all the citations, these are all the documents from where I have retrieved this. So this is the entire philosophy of Nyaya. Right. Now, if we move forward again, these are the three major pillars which we will in depth discuss one after another. So, our agents, we're not using a single LLM as I mentioned previously. We're using three specialized agents, and for to reduce hallucination, to maintain data accuracy, we are using RAG, such that we know that the data that we are using is fairly accurate and fairly true. And the third is the UI part. Like we cannot just simply throw any kind of random data on the UI that, hey, this is the response, do whatever you want to do with it. We need to structure it so that uh, on repeated questions, on repeated queries, you get the understanding, okay, so this is how I'm going to get the data, and this is how I'm going to get the responses. And so that UI, that structure, that is our third pillar. And moving on to the technology stack. Now, this, I'll say this is a bit of like a debatable topic. Specifically, like we don't. Like tech stack. Now, the thing with tech stack is, let's say a couple days, couple months from now, a new technology comes up which is in every way better than this. Then this is completely outdated. Like I'm telling you that hey, use Python for this, and tomorrow when some other languages gets popular, which is much better for Gen AI, then this will be outdated. Obviously, you should use that, and this is the kind of philosophy that we used for while selecting each and every stack. And what our aim was to essentially select the whatever is most popular currently. Because and also the second thing was that we are using to build the code base. We've taken the help of Cursor and Anti-Gravity, and so instead of using some niche language, some niche framework, which even the AI will have trouble creating. Uh, if we use some mainstream language, mainstream framework, so what happens is there is a huge corpus for that AI to use. So there is a very less chance of the code not working as intended, or doing something wrong. There might be some syntax error and all. So the more popular language you use, the less the risk is. So that was our philosophy for that. That's why we decided to go with Python for the core project part. For the agents and all, we used LangChain and LangGraph. And the for we did not use any local LLMs. So for the LLM, we used OpenRouter, and we have in bracket we have Gemma, which is a free tier model that we used. It is very slow. Many times it happens that when I'm making it a query, it will respond with that max key input error and all. But at least for at the time of building, it was reliable. We did not have to spend much money on that. And at least while development, it was a stable model for us to work on. Like you just need to be patient, but you can use a lot of open source, a lot of free software as well. If you did not want to use these free tier agent, you can also use local models, like downloading from Hugging Face and all. But that is entirely up to you, and each and every model has their own accuracies. Like they will be better in one field and other field, and so that is completely up to you. And for RAG, we are using Jupyter Notebook. That is very common now. ChromaDB. So what ChromaDB is used for is, it is a vector DB, and whatever data we are collecting from RAG, we are vectorizing it, and we are indexing it and storing it in ChromaDB. And what is illegal BERT? Illegal BERT. So I'm sure you guys must have heard about BERT. It is the language model. It is not large language model, a simple language model, which is mostly used for vectorizing. And what exactly is in legal BERT? How is it different from BERT? So in legal BERT, it was specifically created to work with legal corpus. Okay, and how do these different models these work is essentially, I'll give you an example. Like let's say I'm just using reading some text from Wikipedia, and compared to that, I'm reading some text from Twitter. I'm reading some tweets and all. Right now it's X, but yeah. So at in the tweet, the context behind an at the rate and some meme, and the hashtag and some name, and these kinds of things, that will be completely different as compared to Wikipedia. So like when you're reading a text from Wikipedia and on a tweet. So when you read some text from tweet and there is written that GUD space N8, Now you are sure to never find this kind of text on Wikipedia. And so what happens when your language model, the one you're using to parse the content, what happens when that data is trained on Wikipedia, and now you're using that to parse a tweet. And the very first thing it will do is it will flag this as something it has never seen before, something that is most probably a mistake, and all. So to minimize that, we have a special we use a different kind of language model which is specifically created to parse the social media language. And similarly, we have in LegalBert, which was trained on a specific corpus so that it can understand the legal jargons and then uh, parse them accordingly. So that is why we used in LegalBert, and there must be some other custom ones created after this. But for now, this is one of the very first ones created, and it's also very popular. And for database, we went with the very common and popular DB. It is very easy to set up with Python as well, SQLite. And UI, as mentioned previously, we went with Streamlit. Now, why did we go with Streamlit as opposed to some other regular front-end framework? Is because currently the entire work we are able to like just have one server which is also hosting the front end backend. And since we did not wish to focus that much on UI, we were able to get away with just using Streamlit, but there are a bunch of downsides for it. Like it is comparatively quite slow, and there is not a lot of decorations and all you can do with this, like basic UI. That's all you can create. You cannot add some complex designs. But for our case and purpose, we were able to get away with using Streamlit. And yeah, in future, if we do wish to expand on this project, then the very one of the very first agenda would be to use a more versatile front end agent. And if we move forward to the data, so one of the very first questions is like, as we mentioned for RAG, we are storing a lot of parsing a lot of data which we know is true. So now how can we trust the data? Like, where is the source? We cannot just Google anything and then take a copy all of the text that it is returning and then paste it here. So we need a dependable source of this data, and for our purposes, we went with the Indian Kanun API. There are a bunch of other sources as well, which we can discuss further. And but for our case, we found that this API, it is returning some well-structured data and relevant data as well. So we can use that, and that's what we did. And now at the end, it is Ragas, Spacey, and XHTML2 PDF. These are just simple frameworks and libraries that we use. I'm sure guys must be familiar with Spacey and XHTML2 PDF already. And what is Ragas? We'll discuss this further in detail. But essentially, now we have already created a RAG, right? Now, who will decide that it is good? That it is returning the relevant data, or it is providing some good source. That for that evaluation, that's why we are using a framework like RAGAS, where it will evaluate our RAG and tell us that, hey, does this look good? Does it not look good? And something like that. So that is why for evaluation, we went with RAGAS framework. And this is our entire technology stack, along with some minor other libraries that were not that essential to the project, but we use them. And yeah, so this is a little bit of a rough overview about how we segregated the work, like to this is not the exact structure that we followed, but this was I'm just giving you a little bit of peek inside the how what the development process looked like at the very beginning of the project. This is when we decided to kind of like separate the work, and how exactly should we do this. So we went with a very modular approach, like each of us can work on this simultaneously, linearly, doesn't really matter, like these are individual block modules, and then we can just sit and connect them with each other. Right now, currently there are 5 developers, 1 reviewer, but what the aim was it is that essentially we have one person will be completely responsible for data ingestion, one will be responsible for agent logic, and so on and so forth. What that does is, like, let's say that I decide to take up the job for dev 2 and dev 4. So now I can take the complete ownership of this, that hey, I will create the entire agentic logic, I will create the entire graph rack, and then just complete all the functions and all, and just share the point of the, let's say, the function call with the UI part, that hey, dev 5 use this function, and then this is the kind of input you need to provide, this is the kind of output that you will get. And then simultaneously he can also just the dev 5 can also directly start with the building, saying that right now this function is empty, whenever I get the function, I can replace it. But this is the kind of response that I'm expecting, and then he can build with that expected response further. This is very common in industry. This is like mostly we use this in our sprints and all. But this is how we decided to move forward. And at the very end, we had one reviewer part, which it was not for any one specific person, but uh, essentially divided amongst us all, that everyone, once the project is done, once all the modules are integrated with each another, then everyone will take up the responsibility as a reviewer and do QA. Everyone, we will try out the chat, we'll try to break it, we'll ask him ridiculous questions and see what kind of responses he gets. And that was the part as a reviewer. Now, if we move forward, and yeah, I have already mentioned uh, uh, a lot of this code base, it was vibe coded. So I wanted to give you a peep into how we decided to like how we were chatting with the AI, and how we were asking it for responses. And um, yeah, we have a bunch of screenshots. Like in the left side, this screenshot, you can see that here what the aim was is that we wanted to add a button in the UI where we can call the RAGAS framework to evaluate our RAG, right? And there was some other button called seed chroma button in a previous development, and essentially what we needed was to add the RAGAS evaluation button and remove the seed button. Now, if you can see that I had properly bulleted points, that what I want from it. First, here it added a bunch of things. I reviewed those files. These 3 files were modified, and once I reviewed, I noticed that hey, now we are using new frameworks and libraries like RAGAS. Now these are not included in my requirements, so I will just ask him in a bullet point that hey, add them in the requirements.txt and also in the YAML. And then now I see that the questions that it is asking, it is not very relevant to my topic. So I also provide some question. Hey, use these questions to these topics. Then I can evaluate further. And I think that still the topics, I think the questions and ground truths, I just had to again modify those myself because they were going out a bit out of the scope. And in the on the right you can see this is further, this is again the UI part where I'm adding the memo button. And here what I've done is I've directly attached the file itself, so that my AI doesn't have to wander a lot. Like, hey, I just tell them, hey, go to the UI and use and change this button. Now, one thing before I get into this, I also like want to share with you guys is that we did not use any paid tier models. So for Cursor, we were using free tier. For anti-gravity also, we're using the free tier. By the way, I believe these screenshots are the from anti-gravity itself. The right one is from anti-gravity, and the left, no, both are from anti-gravity. Correct. So. And so one of the issues we had with this is, like, let's say that I'm using Cursor in the beginning. I ask it to create a bunch of different little things, and then my limit is reached. Now I don't want to stop with the development. What will I do? I would jump to anti-gravity, and then I will start ask it to continue further. And we had a neat little system for that. Like essentially we will decide very small little modules and only build that part. Like here, the entire part of this chat was to simply just add a memo button in the UI, so that whatever memo is getting generated, we can download it. And this is a very small function. And and I'm also along with this, I'm also sharing the file that I want to be modified. What that does is essentially that this does my agent does not need to like go through the entire code base again and again over and over to just find out where it is suggested to modify, which by the way, like usually it only like the Cursor, anti-gravity, these are also smart. They only go through the code base once and then create the context and store them locally, so that even if you close the session and come back later, they can reuse the previous context. But that was not helpful for us when we were jumping between Cursor and anti-gravity, right? So like let's say for Cursor, I ask him to directly make some XYZ change. It parses my entire code base, which uses a set of tokens. Now I'm already short those tokens, and then gives me a response. Now after a bit of back and forth, the tokens expire. Now I don't have the limit. I move to anti-gravity, that hey, I can use this. Now what happens is, when I ask anti-gravity to make some change, it will again go through my entire code base and again burn up those unnecessary tokens. So instead of that, what we did is and also again, like, it does not know what kind of changes Cursor did. Like let's say that I did something, and after half of those implementation, my tokens expire. Now they don't care that hey, oh no, this poor guy, his project is only half completed. No, the Cursor will stop working right then and there. And in that case, it is even difficult for me to explain it to anti-gravity that hey, this was what I was planning to do. First two or three things, these are what is done, and now I want to continue with this. So instead of that, that is why we chose to follow kind of modular steps, that we will expect things, only very small things from AI, And as I mentioned previously, the function is already there, and we have the expected response, we have the expected input, and we are building the function in the backend. So something like this. The specific memo part. Now, I do not recall if the memo was already created or not. Okay, like, are we getting the memo right now? I'm not sure, but we have the button ready, and we are expecting that whenever we call the return memo function or generate memo function, then it will give us a memo in a JSON format. And as I have also mentioned here, view the memo and download in the JSON format. So that is what the philosophy was. That is what we were intending with this, and this is how we used AI to essentially help us with the development. And yeah, before moving to the rack part, I can show you a little bit of the demo. Now, is the agent part visible to you guys, or should I reshare?
You have to reshare, Kaivalya.
Sure. Yeah. Is it visible?
Yes, it
Yes.
yes, it is visible. Yes.
Yeah. So this is our Nyai agent, and currently we have simply deployed it in the Streamlit itself. And this is, for now, as I mentioned, this is more than enough for what we were trying to achieve. And I will just simply add a request to it, like, let's say that I want to rent a flat in Pune. Now I live in Pune, that's why I'm asking you this. Now this agent, it will give me, it will think and give me a response. In the meantime, as I mentioned about the evaluate rack pipeline, unfortunately I cannot show this part to you because it takes about 20-25 minutes, so it is a bit difficult to give you a live demo for this. And this is what the response I get. I can understand the key findings, that hey, what kind of things you should be aware about, what kind of things you want to take a look of. And then this, if I show you the log, I can also give you a little bit of a peek inside how we worked. Like this research part here is where we retrieved all of the documents from the rack. This compliance part, this is where we analyzed all of the retrieved documents. Like here you can see that 8 documents were retrieved, but out of which we only parsed 3 findings. And then this is the part where we generated this response, we generated the memo, and you can also take a look at the memo. This is our memo where all of these findings are added, and we also have the citations at the end, like all the citations where from where we have picked up and generated this response. So what this does is, like, uh, if we want to verify all these data, get a deeper understanding, we can directly go to these sources and also verify. And we can also download this memo. Like let's say that now I think that, hey, when I have the better idea, now I can take this memo and save it for my future reference. So this is essentially how our agent works. And there is a other functionality called chat summary, context summary, but this is not uh, we can discuss this further. And yeah, now with this, I wrap up the first section. Now we can move to the in-depth discussion about RAG. Now, Senthil, do you want to share or should I
You
continue?
can share your screen so that you can continue with my explanation, Kaivalya.
Sure. Just one thing. Before this, if anyone has any doubts or queries, we can discuss those before we start with the next part. And also, is my screen visible?
Yes.
Yeah.
Hey, hi. Kaivalya, Senthil Kumar, and thank you, Pasha, and thank you for the discussion. Very, very detailed introduction of the thinking process there. One of the problems that everybody is going to face
Yes,
is
whoever is speaking, can you speak louder? The voice is a little bit low, and
sure.
audience not able to understand the question.
No problem. Yeah. So, is this better?
Yeah, much better.
Okay. Thanks. Yeah. So I was just, saying that you touched upon a very important and common problem, that we run out of the AI credits or, the tokens and all that, right? So can you just explain that a little bit once again? Like, you started with Cursor, then you hit the problem, then you moved to anti-gravity, and of course, anti-gravity would not, immediately understand that you are coming in between from Cursor side. So how did you manage that, the whole thing? You said modular, but I was not very, I didn't understand it very clearly. So if you can explain that a little bit, that will be helpful.
Yeah. So when I said modular, what I meant is like, let's say again, now let me take the example of the memo part again. That now I am asking a memo to be generated, as I showed you, generated with the synthesis agent, and now that agent is generating the memo. And first of all, I'm not asking that agent to generate the memo, right? Initially, I'm not asking it. So now to generate the memo and to be able to download, there are multiple steps in between. Now, I want to ask the agent to generate. I want to send it to the UI, the generated memo. I want to use that memo to be able to be viewed on the sidebar. And then finally, I also want the memo to be downloaded. And these are four different things. And along with this, the third thing is also that it needs to be in a specific format. There should be citations, all the findings should be there. It should be in JSON format, downloadable, and all that. It should be downloaded. No, I believe it should be downloaded as a PDF. So what that does is, if I ask, now this is all falls under a single memo, right? The topic is memo. Now when I ask Cursor to do this, what will happen if in the middle of the processing the tokens run out? Whatever half done changes it has, it reverts all those back, and now I'm left with nothing. Now I have to go back to anti-gravity, hope that this time the tokens don't go out. So instead, what I do is create small modules. When I said modules, I say that very small tasks, which are complete in themselves. Now I'm saying that, hey, create this button in UI, and it will take some response from the state. And when I get the response, if there is a memo in there, then generate the memo, and it should be visible in the sidebar. Now, similarly, now the second part, I'll go to the backend. Hey, this agent is only returning a summary. I also wanted to return this memo in this XYZ format, so on. So even if after creating the button, cursor runs out of tokens, I can just go to anti-gravity, share the code snippet with it. Hey, this is the button which is already there. I want it such that the backend, in the backend, the agent will create this kind of response that I'm expecting and send it to this button. Something like this. So even if half of the work Cursor is doing, I can just explain simply in one or two lines what that work is, completed work is, and ask anti-gravity to complete further work ahead.
Understood. So essentially, what you are saying, Kaivalya, is small incremental tasks given, so that in a single particular query and response, the tokens are not run out, right?
Correct.
Okay,
Yeah.
okay, got it. Thank you so much. Yeah.
Thanks.
Hi, this is Randhir here. So my question is about the data you are storing in the vector database. I believe the data you are copying is from India Kanun, which is
Yeah.
very static in nature. But consider we are creating a project where data is very dynamic in nature. Like
How will you say that the data is dynamic?
Consider a system where you are saving records about process a company follows, which can be updated depends on what they are working on, whether they have HR documentations or um, any document related to their finance, which could be sensitive too. So I'm just wondering, like, if the data is keep getting updated every day, how you are considering, or what you suggest to copy those data into your vector database, like every time sync up, or do you think about creating a link something to the data source?
Well, essentially, see,
This part we will actually we will cover during the demo. See, in this case, we use the ChromoDB. Okay, so see, the thing is, the judgments. See, you see, right? The judgments they they undergo a lot of revisions, and our agents capture that. So even though the RAG is a static thing, because we may have a grounded information, assume that at least a day old, but assume that now there is a judgment which is passed today, and that is where our agent comes in.
Okay.
And as soon as it is getting uploaded in the appropriate program, the agents will go and revises the memo and provides our output.
Okay. Yeah, we'll check in the demo. Thanks.
Yeah. So now can we move to the build rack pipeline?
One last question.
Yeah, sure.
Mister, is there any way to know that how many tokens are left with us and how much tokens does the task utilize so that we know?
For the anti-gravity and cursor, you're asking?
Yeah.
Well, actually, we have that in anti-gravity. I don't believe we have that in cursor. But in anti-gravity, if you go to the settings and check out the models, there it gives you a rough idea about how much, what percentage of tokens you have left. Let me pull it up and show you guys. Right. Yeah, is this part visible to you?
Yes.
Yeah, so this is the anti-gravity settings. Here, if I go to the models part, I can see these are the models that are available to me, and this is the remaining part. Like right now, in recent times, I haven't used anti-gravity a lot. I'm working on a cursor, so that's I have 100% of the tokens remaining now. It cannot, I mean, I'm not sure it can or cannot, but usually we don't get exact details about how much tokens we have left, XYZ number, because I think with every model it is different. Like this, if a costlier model, they will only give us let's say XYZ amount of tokens, and that is for a cheaper model we have more tokens available. So instead of sharing a set number, they gave us rough percentage about how many, and that is also rough. Like when I use it once or twice, it will still be 100%. Then it will directly jump to 80. This part, 60, and basically in 20% increments. So this is with anti-gravity, and I tried to find it with cursor, but I don't think there is such depiction there.
No, just a clarification at this point. I mean, all the agents have a billing screen, and it really depends on what kind of. So, for example, I think if you're using the premium models like Claude Code and GPT, you can have status lines which will tell you how much tokens were used. I mean, the input tokens and output tokens. That's a simple API call. It can be built into the status lines. Just to clarify. Depends on what kind of interface you use. It can be programmed. I mean, these are all simple API calls to the models. And yeah, I mean, one thing is what Kaivalya said is right. You will get an approximate with this phase calculation. For the actual calculation, the same model has to be queried and it has to be retrieved at our end. Just to clarify, I hope it's clear.
Okay, in that case, let's move on to our next topic, which is building the RAG.
Kaivalya, you have mentioned in the Git that you require API, right, to Google. So does it mean that we need to have a subscription for ChatGPT or Gemini?
Are you talking about the Open Router API?
Here in the environment.env, you mentioned that there is a...
Yeah, that is the Open Router API. No, as I mentioned previously, Open Router, if you go and check on the website, they have a bunch of models, and they also have many free models like Gemma and all, free text models, which you can also use. Like I think there. I don't recall all the free ones. There are a couple of DeepSeek models are also free. Some Google Gemma models are also free. I think some GPT OSS models are also free. So there are a few free ones. These are not always reliable. Like many times they will straight up not work because a lot of people called those and all. But for development purposes, we can use those. Okay, these are a bit slow and all, but we can reliably use those. Right now, for my demo, I moved out of I think in env.example also I shared, right? The Open Router
mention
underscore.
of Google API key. So that is required for default Gemini chats and agents. So do we have to have a valid subscription?
No. That's what I said. Like, right? Right. In the Open API, you can use any free model as well. And right now, I switched to Gemini 3.1 Flash Lite. Before that, I was using GPT OSS free model. OpenAI GPT OSS 120 billion free model. So it's fine. You just yeah, I recommend you go to the Open API once. Check that website out. It has a lot of free models as well for text generation specifically.
Okay.
RAG is set up locally or any online free tier has been used?
I'm sorry?
For setting up the RAG, are you using locally or any online free tier has been used?
We used Google Colab.
No, ChromaDB.
And ChromaDB, that is good. Yeah.
ChromaDB is our RAG vector store.
Okay.
Yeah, Kaivalya, just one request, like whenever it's possible through the session, I don't know whether it's you are covering the code part, but at least let us know from your files or code repository what are the entry points to check, like where is the RAG retrieval or everything, what is for the chart. So it will be easy for us when we study, like where to look for what.
Yeah, sure. I can show that. Yeah, I can show that.
Is the screen shared, right?
Yes.
Yeah, I think you can start sometime. I'll mute myself.
Thanks, Kaivalya, for setting the ground. So now we are going to see how the RAG pipeline has been built into this Nyaya agent. See, first is like we have to ground our source. The thing is, why we opt for an LLM instead of a Google search is Google is open-ended.
Sorry to interrupt you. Senthil, your voice is a bit low.
Is it? Oh, okay, okay. What about now? Is it better?
Yeah, a bit better.
Okay, okay, thank you.
Senthil,
Okay,
you may want to come closer to the
Mike.
mic and speak.
Okay, 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 sir. Okay, so hope now it is clear. Okay, see, the reason why we want, why the things apart from a Google search, okay, and the typical ChatGPT, instead of that, what is the advantage of using a RAG pipeline? See, both uses the open-ended information, the ChatGPTs or the whatever the available LLMs, they use the open-ended information. They don't go and search the actual sources. So now, with the help of RAG, we are going to build that ground truth. And how we are going to use that information, how we are we going to convert it into a form which is understandable by the LLMs, the model, okay, is what we are going to look into this part. And first, we have to fetch our source. Source here, the Supreme Court judgments and High Court judgments. And India Coding API is the one which is created for Indian space. They have created it and they have captured everything in a JSON file. So we will be leveraging it. Okay, and the information, whatever present in that file, right, it is in a raw text. It's a JSON format, and it has some specific metadata. So and also it has a lot of junk codes, and we have to clean up that activity so that we will handle it during our pre-processing. And next, we need to convert
Senthil, sorry to interrupt again. The voice is not clear. I mean,
is
low,
it
very low.
okay?
Imran Saifi will for sure answer your call.
Okay.
Please wait for a while.
Okay. What about now? Still, is the tone fine, or can you please confirm?
You're audible.
Okay. Okay. Yeah. See. Okay. Now, I don't know when. Probably I can restart the pre-processing step. So once you fetch the documents from the India Coding API, the data, right, whatever is present in JSON format, so that has to be converted into a form which is understandable by our LLMs. So before that, we do some pre-processing. So when I say pre-processing, we clean up the white spaces. We used to clean up the not we used to discard the jargons, and we have to discard the unnecessary terms, the terminologies, okay, with the help in the pre-processing step. And next, what we have to, once the cleaned text is received, we need to chunk it and convert it into a embedding vector. So that is what we do here, and that is stored in the ChromaDB in an index format. And the ChromaDB is a place where we so the reason why we import ChromaDB is like it stores all the actual metadata. You see the vector, the actual text, and related stuff in the single place. Probably I can show you during the demo. So that will be what say we get everything in a single place, and especially with respect to a legal right where the content is very, we will be having very lengthy documents. Okay, so every time we don't need to go to a different place to see the to get the text. So ChromaDB helps us to avoid that. Can you move on to the next slide?
Giving
Yes. This is the more. This is the more.
But then how do you maintain that? Right? Because then you need that same AI to maintain it long term.
Okay. So first step, as I mentioned, is we are going to fetch the data from the India Coding API, and here the output you see is a raw JSON file. So that is what, and it has a ID and the title of the judgment, and so we have the code, so which code has provided the verdict and when it was published, and the documentation, actual documentation where the judgment details are provided. So this is the structure of the JSON file. And next, what we do, we have to pre-process and chunk it. So this is where we have to clean these stopcodes and the citations, like see some case .a or some SSC something. There will be some legal terminologies which we have to clean up. So that step we do in the pre-processing, and here also we do a label mapping. See some of the, I think the legal personalities, right? They'll be looking for C terminologies like judgments, held facts. So what are those things, right? So we have to tie that. Our chunking is based on these labels, because it's a sentence of chunking. We need to segregate these components from the judgment, and we feed this. And our chunking in this case, right, we use a overlapping chunking method, where it's a 400 um, token length of 400 token length, and 64 token is the overlapping, and so that we don't lose the context. And once the chunks are generated, we provide this information to the in-legal bird, which is the legal version of the, I would say, like the customized, which is customized for legal connotation. Because a normal BERT model, right, assume that you go and see things bench, assume that we always hear the term like the division bench, Supreme Court bench, or something like three-judge bench and all, right? So the context difference, like when you see that in the normal English, right, the bench refers to the place where we sit, but in legal terms, this bench refers to the judgment, or the place where the judges sit. So those kind of meanings and all, right, which can be easily leveraged by the in-legal BERT. So that's the reason we are opting for this model. Yeah, and one more thing is like what so okay, in this model, right? So we have used the cosine similarity index, and we normalize. So whenever we see two judgments, right, we don't need to repeatedly refer the same judgment again and again, because since we normally
Senthil,
use.
I think you will have to come closer to the mic. I think the voice is fading when explaining. Or is it just me, or is it for everyone?
Yes, Jai Krishna, we are not able. It's not clear. I mean, we are
Is it?
able to hear, but it's very, very low.
Yeah. So, Senthil, can you come closer to the? I mean, you can keep the mic closer to your face, and then speak. I think then, because in between there were sections where you were very clear. So if you could just speak a little bit more closer to the mic, it would be very audible for everyone.
Oh, okay, sir. Okay. Okay. Okay, so let me recover the legal BERT part. So the legal, okay, we know the BERT is one of the type of transformer architecture. On top of it, we have this in-legal BERT, and here it is more customized to the legal context. So that's the difference when you use a normal transformer architecture and the model in legal BERT. Here, as I was quoting an example related to bench, right? So bench is something where we normally sit, but in legal terms, it will refer to a division bench or a three-judge bench in a Supreme Court or High Court, like that. So that difference you can easily leverage from when we use the correct model. And here, one more thing is we use the cosine similarity. We leverage that cosine similarity function because some of the judgment, most of the judgments, right, they may be leading to a similar verdict. So in such an instance, when we normalize them and use it, we don't need to repeatedly refer that information. Instead, the vectorized format, right, it will know that okay, it is already captured. So we don't need to repeatedly duplicate the information what we are looking for. So that advantage also we have when we use this. And next is once the embedding part is completed, and then you say embedding, right, it is a vector. So all the text are converted into numerical vectors. Then we have to store this in a ChromaDB, and ChromaDB uses the hierarchical navigable small node, where it's kind of a model, like assume that it's kind of a tree structure. where in the initial phase it will be very sparse, but towards the bottom right, or once you reach the initial, once you navigate the initial assume that assume that you have a tree-like structure where on the top layer you see the highly sparse vectors, and it will try to find where the word is very closest. And once that is found out, it will go in depth, and then it it do the in-depth search. So that is the purpose of this algorithm. So we leverage that in ChromaDB for this. And finally, when you see this, right, this database, right, it is locally stored. At least in my case, right, I built it where this can be stored in the Google Drive, so that I know what kind of information is fetched and how it is stored. All this information I can visibly see, because from a developer point of view, it is always useful to see what kind of information, because you always you have to verify the information you are trying to provide. So the thing is that your algorithm has fetched the correct information or not. That you need to know it. So this was locally stored in the drive. Before moving on to this next slide, do you have any questions?
Yes.
Senthil, one minute. Can you also share your screen and show the Kodak part?
Oh, yes, coding part. Okay. Sure.
Yeah, that would be helpful. And Senthil, this diagram is very useful. Maybe, if you can run through an example like what Kaivalya was showing, like, for example, renting a flat in Pune, then what happens, like, in each step. What do you get from India Kanun API? Then how the whole thing happens, and then that was question one. Question two. Did you say that you are using the ChromaDB on your local
Yeah, Google Drive.
device?
It's a Google Drive.
Google Drive. Okay.
And also for your first part, we're not dynamically fetching the data every time we ask a question or we make a query. This preparation of the RAG, this was done separately. Like we fetched a bunch of data from this API and then passed it and stored it in the RAG. And then whenever a query is being made, the data that is already stored in the RAG, that is the only thing that we are using. If we're not fetching data from Indian Kanun at that time. Because one of the this does slows down not slow down actually. There is a lot of, as I think Randhir also mentioned, that some source data might change and we might not be aware about this. But there are two things two reasons behind this decision. The first one was that, first of all, when we are fetching the data from Indian Kanun, we are a part of that loop, right? A human is part of that loop. We cannot depend on AI to in itself decide what data it want to fetch from the API and then pass that data, store it in the RAG. First of all, it will be slow because parsing, pre-processing, embedding, indexing, all this takes time, and then we also want to fetch along with this. So first of all, it defeats the purpose of actually storing the RAG. Like if we are anyways fetching from the Indian Kanun API, then instead of depending on why are we even vectorizing and embedding into the RAG? We can directly get from API. Now, what that does is it adds dependence, it removes dependency from us and adds that dependency on the Kanun API. So when we are fetching the data, if the Kanun API returns relevant data, then the response is relevant. Otherwise, that response is whatever Kanun API is sending, right? So that's why what
Understood.
Yeah.
So you would have already pre-fetched data for some specific use cases, right? You can't do that for hundreds of use cases, right? Okay.
Yeah.
Okay,
That's what my question was, Kaivalya. Like, I mean, I'm completely agree on that this scenario is completely working fine and should be working fine. if you are just copying the data and the human is in the loop to copy and setting up the database. But consider you are creating a new project, and that's why I'm asking you, like if I need to create a new project where the data is getting very dynamic in nature and not like before the call, but consider you are refreshing data every night so that it will be up to date for any kind of scenarios. Consider a company has HR policy which is getting updated every quarter. That should be some kind of process to get populated, getting the delta or refreshing entire database. That was my question was in that context. I got that this
Yeah,
will work fine, but I'm considering different scenarios.
yeah, no, Ranveer, see, in that case entirely, we can say that RAG embedding as vectors and all this is not that good of a approach. In that case, you should not use RAG, because RAG we are see when we are even when we are taking a very small subsection of the data, like just barely, I think 800 to 1000 JSON files, and we're processing them based on the local device. It can take up to half an hour, 40 minutes to vectorize. Complete the entire process from fetching, parsing, pre-processing, and then embedding, then indexing. All of this, it can take up to about 30-40 minutes. Okay, so if you have a bunch of data that is updating every day, every night at 12, the entire data gets refreshed, a lot of things are changing, then preparing a RAG is not that good of a solution. Then you can take a look at the others, and like you don't exclusively have to vectorize the data. Okay, like you can directly use the PDF, just store the text. In that case, you don't have to
Kind of
convert
link.
the data. That will be less relevant. So there is a like most of the time RAG, it is used for let's say like the legal. In this case, it is not every day that the kanun changes, right?
That's what I was thinking too. Like this case is perfectly fine. Yeah.
Yeah. Okay. If we have any other question, otherwise Senthil can go ahead
So
with.
yeah, just to summarize, Kaivalya, basically, the for specific use cases, the data is fetched from the India Kanun API, and that pre-processing step was shown. That was basically essentially your human in loop before doing the embedding with the in legal but is that right understanding?
Yeah.
Okay, cool. And just curious, I mean, I don't know if you're going to cover it later. You can answer in that can be answered later. So, like the Gamma, the use of Gamma and SQLite DB, that can be covered as well at
Yeah,
appropriate time.
that will be covered later.
Okay,
Right
okay,
now, we can. Senthil has shared his screen.
okay,
He will demo the rack preparation.
okay. All right, thank you.
Yeah, actually, I have ran this pipeline already. I will reline certain steps and then. So first of all, we have to run the required libraries. So where the request and beautiful soaps are basically to leverage the HTMLs, and the language detect is to detect whether the judgment is in English
Senthil,
or
sorry
is
to
it.
interrupt you again. Like your voice is not
Oh, is
clear.
it? Okay. So now, okay, hold my mic. Okay. So first is like you see for making HTTP calls or HTML tags, right? That will be used that you can use request and beautiful soap. Next is language detect is basically for your to detect whether the judgment is in English or not. And Spacy is to split the text into sentences, which will be required for our chunking. Then we have to use our sentence transformers. This is where we use our in-legal word, which converts our text into vectors. Then comes the ChromoDB, which is our vector store. And next, LangChain community or for building the agent pipelines. Okay. And the transformer, we use the Hugging Face transformer where this is to load our pre-trained models. So these are the some of the key libraries which we are installing it. I'll be restarting it so that in the next session, we don't need to do this. Okay. Next, I'm mounting my drive. Let me refresh it once. Okay, so actually, so this is our the thing is here we say I have given mentioned the path where we are storing the chroma DB vector database as well as the data which we fetch in the India Canon in a raw data file. Okay, it will be in the JSON format. So this is how the data will be stored here. You can see all this files, right? So each and everything. These are all are related to the inputs I have given. I have given some queries related to the SEBI insider trading and contract loss, and I have set a limit. Okay, so I need documents up to 50. I am up to 50 documents I am trying to go into fetch, and also the length also I have specified. So that will be based on the specification. We receive these documents in this folder, and you can see this structure of this JSON file. You can see this, the title ID when it was published. So this is some random judgment which was so what is the title of the judgment and the details. Okay, the document, everything will be present here. And so you see this, right? This is in a JSON format, and you see a lot of special characters to handle these special to the escape characters, and you see unnecessary spaces are there. So that is what we need to do, the pre-process this information. Next, we use the Grok model here. So actually the open router key is expert, so we use this Grok API for this demo, which you can easily get from this. Okay, you can click on this link, console.grok.com keys, and with a simple registration, we should be able to create a key. And so you will go to a page like this, and you can simply click and generate a key. Okay, so which is very easy, which is simple. For our demo or for development purposes, we can leverage this. You can set the expiration. So for now, I just set it to 7 days. Okay. So once you look at this, you copy this information and you can store it in the Google Secrets. So here you see the key icon. Okay. So I already stored this information, so I'm not going to use it again. But this is how you have to define the keys and store the values so that your pipeline leverages it during runtime. The two keys are required. One is the India Canon key and the Grok API. India Canon, you have to it's the same approach for India Canon also. You have to register in the India Canon website, and so you have to provide a justification why you need the key, and be informed them, okay, we are going to do some demonstrable projects for our academic reasons. So they provided this. They take a time to approve it, and after that they grant access to it. And once we receive these keys, right, then next step is we have to fetch that information. So we use the request library, and we also, since this files everything is in JSON, so we are using the JSON to read that information. These are the first we search for. Okay, how do we? Okay, we are based on our query. It will go and search for the documents, and here if you see this, right, it fetches the documents based on the ID. And at least see the things in this, since it's a small piece, right? So here we have set the limit to 5. But the more I think most of the judgments and all, right, it may run into hundreds and thousands of pages. So in such cases, you can. So the thing is, it is a choice of the developer to see how do you decide, okay, whether you need a lengthy document and the document has to be very minimal. Those and all you can restrict using the fetcher pipeline. And once you fetch these documents, this corpus is being fetched entirely. At the max, for a single query, I set the limit to 50 for now. So these are some of the queries I have for the demo purpose I have given. So inside you can also try with some other, some of your own, which suits your own interest, right? You can provide the queries there, and it will fetch the documents related to it. So for each, assume that you have some 5 queries here, and each query, 50 documents will be fetched, and all that will be present in your in this point here, the raw code one, right? So this will be having totally 150 files in this case now. Okay. So this is how you store this, get your raw data. And this information so this is the project directory, and within this project data, I create a one for the vector store, next for the store me raw data. So you can customize this based on your requirement. And the reason you see it, so the reason why this was stored, you can see it when I refresh, I didn't lose this information. I don't need to fetch this information again. I can simply use it. So that's the reason. And ChromaDB also, let me go to it. I haven't run the ChromaDB now, but if you see this, right, it is already have that right information here. Until the session is active, so even if it is lost for, right, you should be able to leverage this information. Now moving to the next part where we pre-process and chunk. So this boilerplate, okay, when you typically, how do we parse a HTML page? So the boilerplate template, right? So we leverage that existing thing. And here next thing is when it comes to judgment, these are the keywords. What is the judgment, order, held? So these are the judgment and order we are familiar. So these are some of the terms which are legally the person who is familiar with the subject knowledge, they may be familiar with, and they can include more information on this. So based on the headings, and we label each and every heading. Okay, so based on this, who is giving the opinion, which judge. So this information is all tagged here. And next, we do the pre-processing where we can see this, right? We can just separate with a new line. This step we separate with a new line and replace the empty spaces. And we also replace the text tabs and other special characters. Okay, and one more thing is we normalize the text here. Almost everything is converted into small case. And the citation normalize is very it's very specific to the legal. That is.
मैम आपका जूनो लॉगिन पार्लेवार पीक्यूआर टारगेट है टीबीएल बराबर
Pardon, was that a question?
I think please ignore him. Go ahead.
Okay.
Okay, so these are, and once what happens, right, after that we are trying to get this information, what is the title ID, because we have to tie our, so whenever we need to do a citation, right, so there is a question, okay, how do we tie the information, whatever received, how we are going to tie, this one will help us. Okay. So once we extract this, so okay. And next step is we are going to chunk. Okay, so the chunking strategy, in this case, in legal bird, it's a 786 token. The model, right, it's 786 token, and we use 40. And the overlapping token is 64. Because some of the cases we don't need to. The more the tokens you use, right, the chunking may become sparse, and it may take longer time to retrieve the information or for any comparisons with limited. So optimally, we have to. This is a trial and error stuff, but based on the conventions, so we went with 400. So we can't use lesser one because we will not use, because when you use lower chunk, say 100, right? So it is very small, and that means we will be having too many embeddings, okay, and it will take longer process. And 600, you may end up in a sparse vector. In that case also it will be a problem. So we need to identify something in between so that your search is going to be very optimal. And this is the part which covers, so this is a sentence over time, and here if you look at this, right, we look for the labels and then chunk it. So here you see this label. Here you see the label map. So which was defined in the previous section. Here it is. So based on that, we can define how we are going to set, because we are familiar with the structure, and these are all standardized documents. Okay, and so in case
శాంతి చెప్పు మరి ఇది
these are all standardized document which follows the convention. So it is a little bit easier for us. Okay, the basic understanding. Assume that we do some manual effort to understand how the document is structured. Some scatter some 5 or 10, 15 documents if we go through, and it may follow a repeated structure. So we will be leveraging that. And we don't need to scan through the entire data set to see how these documents are. And once this is done, after we chunk, we pre-process. When we say pre-process, we remove all the unnecessary citations, the white spaces, and any jargons, which is in legal terms. We will remove them, and after that we send it to the chunking. The chunking is one of the time-consuming activity. In this case, right? So my chunking almost took 15 to 20 minutes in a case. Pre-processing is a little bit easier step. So, okay. And so coming to the next step is where we are going to feed our model with the chunked data. So this text, you see this, we are providing the chunked text to our model, which encodes the information. So you see we have a lengthy paragraph which is converted into small chunks, and next step is we are chunking that into a numerical form. That is why we use this model. Okay, we use the same model to encode and decode. That will be very helpful for us. We should not ideally write. If you use a different model to decode, then the vectors may not be aligning, and we may end up getting wrong outputs. So this is what I have mentioned about the normalized embedding, where in case if the judgments are very similar, and so it will be tagged under one. So we don't need to duplicate our search. And let me show you the chunk dimension. So totally, if you see this, right, we have this is the size of the matrix. It has 2198 rows, and each of 168 dimensions. Each vector, the length of each vector is 168. And one more thing is you see this batching process. So instead of chunking, so this is where we leverage our GPUs. Instead of chunking one by one, we leverage in a batch of 64, so that all happens in parallel. And you can see this, right? Okay. So someone was asking about the information, right? So these information is model safe tensors, these local tokenizer config file, and special tokens. So assume that in case if you use some special words, so special tokens. So all this information will be captured here, the special token maps. Present. I think this one should be present in the cache. So let's see if we can get that. Okay. See, normally you get something like this. Okay, when you so this is for a different project, but I'm showing you. So once we export this model, that you will be getting something like this. The config files, you see whatever here, training Georgia from special maps, tokenizer. So all this information will be stored here, and the only thing is we need to redirect our output to a dedicated directory so that we can see. Because especially when you are trying to build a model, you see the thing is in the first after a few iterations you choose a model, and you will be setting there as a champion model. And when you use this champion model for your inference, there may be some gaps, okay, and when there may be some gaps in the sense, so you need to see, okay, whether the model you have exported is correct or not. So at in this situation, your this configs, this tokenizer, right, everything will be helpful, because these are the informations which this information, right, which was based on the instructions whatever you have given. This will be rebuilt. The special tokens and all, right, it will be rebuilt. So I can show you, but this is not for this case. This is for a different project, but this is how normally you get in token information. Okay, so unknown tokens. Normally, this are used for a DeFi transformer. So these are the default ones. It has end of sentence and the path for padding and unknown. And apart from that, these are the 5 additional examples we see that here. But similar information you should be able to get when we try to when you seed in this model with additional tokens. So when I say additional tokens, you can also say the labels. Assume that if you want this judgments and already, if you want to give this a special token, so that information will come here. Next is the ChromoDB. Okay. So here so this is our metadata. So I was mentioning about the question similarity. So the documents are we do a similarity search based on the question similarity function, which is that means you use a normalized vector, right, to compare two documents. Give me a moment. Okay. Okay. So now, so once we prepare this chunk, right, we need to store this in a vector DB. That is where this we use this ChromoDB for our vectorized storage. Here, if you look at this, the question similarity. Okay, so the other option is hopefully you should be familiar with the equivalent distance, where we get the instead of the normalized, we use the actual distance, which may not be efficient in this way. And next is the construction here, which is how the graph is built. I was talking about the HNSW structure, right, a hierarchical structure. So the 200 is the configuration I have provided, but in a typical scenario, higher the number, better is the quality. So next is the 64. How many neighbors you are going to tag under each node? So this is the configuration of our ChromoDB. The next is this is where we store. We use the upsearch strategy, because I was talking about whenever assume that you get two similar judgments, or which is more relevant, right? The value gets updated here. This. So this is the one which was created as part of this ChromoDB. These are all binary files, and I was trying to open it, but probably we may have to spend more time on understanding these things. And this is our ChromoDB. Okay, and here we don't have a mechanism, but probably in your local, if VS Code supports it, you can also leverage this and see what is present. And assume that instead of you using a Google Drive, if you use a Olama version, which is here I have used Chrome, if you have used Olama, which allows you to set up a localized environment, and you can store your information locally on your device. So in case if you can, since it's a SQLite file, right? There are some extension available in VS Code, which can be leveraged to see what is the actual content present here. Okay. And finally, the RAG pipeline. So we have built. Okay, we have fetched the documents We have completed the pre-processing. We have converted into small chunks, and we also fed the chunks into a numerical format with the help of the Chroma DB. Now, next is comes the query bot. So we are giving an instruction to Grok that, okay, see, you are an agent. Okay, that is a legal research assistant. So that is, we are setting the context. Things, anything, if you are asking anything beyond legal search, it may give the answer. So it's irrelevant in this space. So we have to be a little bit specific because this is something like where you are grounded your truth to a specific domain. So it's not a generic domain, it's a specific domain. You can use anything in case of legal, in case you want to use any other sources, you can also use that. And so we provide this, what is the message and the context. What this is, we provide in the question. And next is the authorization. It authorizes our request and come up with a response. So similarly, I have tried with the Gemini. So I have some difficulty in getting the Gemini key, so I went with this Grok itself. Ollama is the local version. Assume that if you are building this entire pipeline like how Kaivala has built, right, you can use it directly with the help of Ollama. And this is the RAG query. Assume that on the moment you send the questions, so your questions will be converted into a numerical embedding. Again, we use in this model, right? This model refers to the illegal but sentence transformer model. Okay, and we provide some mechanisms. So how we have to, what kind of responses we are with that we are providing here, and what it has to respond with the documents and the metadata and the distance. When I say distance, how similar between our query and the document it has fetched. It builds the context blocks. So the thing is, it may retrieve more than sufficient number of what is required. So we have to re-rank it. So that is why we use this here. We limit it here in this case to top 3. So this is how our backend works. This is the code I have given. What is the penalty for inserted trading? So you can see this response, right? So it has come up with a response, which is very specific to this. And how do we ensure that? Okay, let me move on to. So okay, now this one was built. Okay, how do we ensure that whatever we have retrieved is correct or not? So again, so that is what we need to see. But what are the models? Okay, where it was? What are the retrieve chains? How? What is his code? You can see the similarity matrix is 0.802. So we have set the 0.8 is assuming this case, right? You have seen the similarity is if the similar 0.80, that means the relevance is very high in this case. This is how you have to see, and probably we need to refer to this. So ideally, right? This is where your that memo comes, right? So what are these legal citations? So this is how it is being fetched here. There are different ways. One is this relevance. Next is faithfulness. The faithfulness, how truthful is your information is. And here we have score. I have set it to 70, but you can because higher the score, that means you are getting a more high relevant information. But sometimes that even assume that you don't need to set a very high score, but some information you can get it with a very assume that in the 70 to 60 range, 60 to 70 range. You may get the context. Okay, why this was in 60, 70. That is from a legal point, the person will understand why the case didn't go through. That information probably with modifying this score, you should be able to get that the same setup, but here we are checking the faithfulness. It is the top 6. Okay, so top 6 answers, and see this is where the faithfulness score comes, and this is the output what say we have received, right? So this is the output what we have seen in our in the previous section. And citation traceability. So this is where we see what is the document, this number and all you see, right? How we are going to, because this is very critical, because see, whenever I think that um, when you are productionizing this, right, and you always need to know. So we don't need to completely rely on assume that this question, because Kyle was telling a case, right, where so he has generated a response and that was shared with the judge, but it was out of context. That is where we need to the help of the humans. So it's not that we are not going to bypass the humans. We are going to see, we are going to aid them with more accurate information. And so this is where we are giving that which judgment it was tracing to. Probably I think I should include the CID so that it can tag to the JSON file exactly. So in this way, this is some of the mechanism you can check. And this is assume that you know the ground truth, assume that you already has, assume that the legal person has already paid for a judge for a court case, and he know what has happened. He can provide the question and he can see what he can see the answers. And now we can try to ask our app, okay, what is the response? And that is also one way you can check that. So the ground truth check, where we see the LMs with the actual answers. This is kind of a few shot prompting. You can try this also. And finally, this manual spot check. So where we manually go and see to each and every. So this is where we have this title ID and all that. The title ID is still okay. I think I didn't include the title ID, but normally you can go and search for the titles with the help of CAD. So it has the more detailed information. So these are some of the ways. Okay, apart from you generate a response, you also need to ensure that how faithful and relevant the answer you have generated, which will help us to navigate the real-time challenges, overcome the real-time challenges. Okay. So that's all from my end. So I'm open to questions now.
Yeah, so there are a few questions that have been posted in chat. I think, okay, I'll just read the very first one, which is, I mean, from bottom, I'll read. So I think this is ND who has asked, did you create the chunks of 400 tokens for embedding text to numerical using invert legal? If yes, how did you reach to that specific numbers? Do you cover specific structure in each chunk? This is regarding the chunking of the tokens, I guess.
Oh, okay. Yeah, actually, see, okay, see, the thing is, in legal, see, there are some, for each and every model, right? They have their own dimensions. See, this is one I was talking about, right? This is for a separate token map. Okay. So this is the default it comes in. Okay, let me see, try to get the example so that so the moment, okay, so this one is for a DeFi model, but in this case, I am not storing it. Okay, so that's the reason. Okay, if you look at this, right, it will have all the model parameters, whatever it is using here. And this is for a DeFi token. And similarly, we can also get it for illegal bet also. And that with that help, right, you should be able to see what is the maximum token length it can allow. See, in this model, this D model is 768. So when I was so this is the config file, okay, and here normally So you see this, right? The shape 768. So that means the model, the default length of the model, right, for each input is by 768. And here, okay, how do we decide the tokens? Okay. There are three options. Okay, see, the thing is, normally when we chunk the data, not everything fit into the 768 length, and we also have additional the default see, which is what to say, the placeholders, okay, for the BERT model. And okay, we need to decide the optimal level. Okay, so the thing is, how do you decide it? Okay, you have to 768 we can't directly use, but you can first you can try with 600. And how do you modify is based on the response, right? For example, when you have a very higher limit, right? Then in that case, what happens? You may not get the correct contextual information because assume that when you have chunked it into 600, but the judgment is not fit into 600, and it may fill in with extra spaces. And when you do a overlapping, the overlapping will not make sense in such a scenario. So that's the reason we have to identify some token which is in the middle, say 300 to 500. Probably the best approach is you have to work it out and see, okay, when you give 300, what happens, 400, what happens, 500, what happens. And based on the response, right, because it will also result in degraded performance. The more, assume that when you give lesser tokens, right, the model itself will take more time to complete. Think that in this case, you are having this 21928 into 768. Okay, this is the one embedding attached design. So you know the dimension, and you are dividing it by 400 with overlap 664. And see, even though we have think that you do a rough calculation about how you are splitting it by 400, 500, 600, and see how overlapping the document will be. So that is a kind of manual stuff we have to do. That is, that comes with some practice or some
Understood. So you tried few things, and based on that, the
Yes.
optimal number of 400 was decided.
Yes.
And the next question was when the same thing. Next question was like, in this embedding, are you following certain structure because it needs to be meaningful, right? When you store it, otherwise the query will be incomplete, right? It will not be
Yes,
fully
yes,
contextual.
yes, yes. That is why we use the legal map. So in this case, we have defined the tokens. We have defined the legal maps in the year. So we identify for based on this.
Understood. Okay. So all the data needs to be fit it should be matching the structure and within the
Yes.
400 tokens, right? Those are the two conditions here.
Yes, yes.
Okay.
So if it is, even if it is exceeding, right, the overlapping method will help us to identify, try to get that
Okay.
knowledge.
All right. Thank you so much.
A quick check. I see hand raises. So before I come to hand raises, so I'm pretty sure that an email was sent either on Tuesday or Wednesday with the resources for session 1. If you have not yet received it, do not worry. We are collating all the details into a common repo. I'm sharing that repo details in the chat. So this will also be separately shared via email. So this is critical resources, websites, podcasts, blogs, etc., and some token calculation logics, when to use which, some basic heuristic based on whatever we have seen across. This has been populated over here, and each session details will be populated at the end of the session. Okay, so this is just a operational comment. Let me just take one hand raise, a couple of hand raises. The first one is Vinay Kopade. Yeah. Vinay.
Yes. Are you able to hear me?
Yeah, you are audible. Please ask your question.
I saw something function called like faithfulness. So I didn't understand what is that, like whether it's a part of compliance agent, like you mentioned also, like
No, it's not related to the complete. It's based on, see, this one is related to the RAG. How do you verify the input information, whatever we have received from RAG is correct or not?
Yeah. What is the general technique for doing this? Like what we check in this?
Yeah, here we have used relevance and faithfulness. In this case, there is relevance in the sense based on the similarity score.
Okay. Okay. And one more whatever the code right now I see and whatever we got it into Git report is different. It's like in the
Yeah,
current Git
maybe.
report is missing some last part like you
Yes. This
showed
one
that.
I included after the review comments. This was whatever the Kaivala shared. It was developed. It was built during our development time, and this one was we used to validate during our sessions. So probably I will share this updated one with Kaivala so that you can see the latest version.
Yeah, so the latest versions will update the repo and the changes, etc., will be commented in that. So as soon as the session ends, we'll make sure that the latest resources are available in the GitHub repo.
Mhm. Yeah. Okay. And one last question is like when we show the citation, like will it be list of all the documents that we retrieved from the RAG, or
No,
like
based
you
on
mentioned,
yes,
you
yes,
mentioned that compliance model will filter, compliance agent will filter from that, and so only filtered citation we show, or we show
we have
everything?
we have a threshold check. Okay, see the thing is you see right. So we see a 0.80 is the number of chunks. Okay, see it may see the totally you see the initial in the top right. So how much document was fetched for each query.
So, but you are
Yeah.
filtering that
Yes. So from the
response afterwards
yes.
by the compliance agent. So
No.
in a
Compliance
site,
agent is not in this part. This is completely RAG one. The compliance Kaivala will cover that.
well, okay, fine. Yeah, that's it from my side.
Thanks, Vinay. There is a question from Randhir. Randhir, you can unmute yourself and ask the question.
Yeah, thanks. So my question is about the similarity search you're doing. I believe in this case, we need to find the exact information from Indian Qanun. Why? I mean, I'm just trying to understand like why we're not doing the exact similarity search and doing the approximate, which is cosine.
See, actually, each and every judgment is unique, right? So the exact matches will, what to say, will
So
get
my
more.
understanding
Okay, see,
is
exact duplication, what I understood basically, right? So the thing is, it will create more duplications when you go for exact similarity score.
sorry, come again.
Okay, so when you go for the exact match, right, you may end up in getting more output, duplicated output. So it will be redundancy. So to avoid that, we are going with the approximate.
Okay. Okay, thanks. Yeah.
Okay, one final question from ND.
Yeah. Hey, thanks. Thank you, sir, and the team for patiently answering all the questions. So, I'm not sure if it is already covered, but uh, the usage of the Gamma and SQLite, if that can be covered, unless it is already covered. And the second part is, you used a lot of Python libraries, right? If you know high level, high usage Python libraries, if those can be described, that would be helpful. Or otherwise, when you clean the repo and document it, you can cover it just there as well, in whatever works best.
Okay, sure, sir. Okay, because actually we will provide update the README file with necessary information.
Hi, Senthil. Like one question, like as we discussed earlier, like we are maintaining three agents, right? One is for research, one is for compliance, and one is for synthesis, right? Like whatever the code you have, you are showing, right? Like fetching the document from CanGrab and doing chunking and embeddings, like all are these three or the comes under each agent, or like all whatever enter this process, whatever is shown, right? This is one agent.
I would say like this is a base agent. Okay, this is also see agent It's something like you use the underlying LLM, right? So still uses the underlying LLM.
Senthil, you may want to show the block diagram, and Kaivalya had shared a block diagram, right? And you can just tell from there, yeah, which one was used, which one was described right now. I think you described the RAG part of it
Yes, yes.
alone right now. Yeah.
Yes.
Yeah,
Kaivalya,
let me share the screen. Something. It's fine. Is it visible?
Yeah.
Yeah. So currently, this is the part which we discussed. These are the three agents. These are a separate section. Right now, how do we populate the RAG? This is what we discussed, right? And there was a small section about fetching the data, fetching a response from the RAG, but that is just for our testing purposes in the notebook. The actual agent part, now we will take that up. Right now, Senthil focused on how do we exactly populate the main part of the project, right? So without a RAG, if we do not have any data, these agents can do nothing. So how do we, the most crucial part is populating the RAG properly. Like when we are adding the data, when we are fetching the data. So that is what Senthil covered. And if we are done with the question for this, we can move to the second part, which is the three agents. After which we will take up the third pillar, which is the UI and RAG evaluation. So that part, yeah.
You mean Kaivalya, like whatever the diagram you have shown, right? That means only that fetching from CAN API and the storing and doing some operations like transformation, like chunking, embedding. That is the process we discussed. That also can we say? I mean, technically as a one RAG. I mean, it's not like agent, right? It's just
No.
like,
It is not any specific agent. We use the agent to just test out the data, but that is, I mean, that is not part of the three agents that we are speaking of right now.
Okay.
These
Generally, one general question, like generally RAG means like there also we'll going to see in the current process what Senthil has shown. There also we are trying to hit LLM and fetch the data and doing some manipulations, right?
Correct.
And even if we go with the agent, other three agents which we're going to discuss, right? There also we going to hit some LLM and fetch data. For one might be some, like as you mentioned, like some such another agent, I mean compliance agent. Like there also, I think we may hit some another LLM and we'll do some other operation, like some lookup you have mentioned in the diagram, right? Yeah, that mean what is the? I mean, basically all these things will doing the same thing. I mean, work is different, but internally hitting LLM, correct?
Yeah, that's what we will go into right now. Okay.
Okay.
Yeah. So if we are done with if everyone is done with the questions for RAG, then we can move on to the next part. Okay. So I'll take that as a no. Let's go to the free agents part. Now, this is the architecture. Now we have used LangGraph, LangChain for the graphs and all, and the very biggest question I'm sure everyone is having, a couple of you have already asked me, like, why are we using three agents? Okay, I mentioned it already multiple times. Three agents. Like, why? Why not just use one LLM and ask it to present me the response? And now in that is, this is a similar kind of questions where question for why are we even using a RAG? Why not direct? I go on my phone, open Gemini or Claude, and ask it for a response. So this is similar to that. We can do that, but the sense of we can say that when we are using three agents, we have balanced these three agents to specifically complement each other. Each agent is only working on one particular task. That is why we are calling it a specialized agent, such that we don't have to worry about it ever missing the context, missing what it's supposed to do, doing something else, and something like that. The more responsibility you give a single LLM, the more the chances are for it to mess up. So, but similarly, that's why we are using more than one, because right now we're not only generating a response. So, like if we go into the details, so what exactly happens when I am calling, I'm as a user, I'm generating text, I'm asking it something. So this text, it needs to be understood by the LLM. Then it fetches the relevant data. Then it reads through the relevant data, checks whether or not it is actually relevant or not. And then after that, it summarizes the entire data. It creates a memo. It highlights the citations. And during all of this, one single agent, we are expecting us to do we expecting one single agent to do all of this in one go is setting ourselves up for disaster, right? So like when that's why we are using more than one. And why not 5, why not 6, why not 8? So we can, no one is exactly stopping us. Like it's not wrong to use one agent, it's not wrong to use 5 agents, but it is our decision to see where the sweet spot is for us. Like for our case, we see that one singular agent was putting a lot of responsibilities on a single agent, and 5 agents when we are using, then we are segregating very minor responsibilities among different ones, which is not really required, I might say. Like for our case, 3 different agents was sufficient, and that's why we chose to go along with it. I think we have a flow chart, and here now I can explain what these 3 agents are and what are the roles and responsibilities of these 3 agents. And let's move. So this is the entry point. What is the entry route? Whenever I enter a prompt, whenever the user enters a prompt, this is the entry route, and we have set up the entry route such that we can go to the RAG. This is our ideal pipeline, and this is also the plain chat. In case RAG is not functional, then we can simply tell the user that, hey, currently we are not retrieving from RAG. This is a simple chat with some light system prompts. We can go over the system prompts in the code part. So we have 3 agents. The very first agent is the research agent. The only responsibility of this research agent is to, whatever prompt I get, go into the RAG database, retrieve whatever the relevant data it finds, and then send all these relevant data to the compliance agent. Like let's say I ask it anything XYZ. Again, let's say I ask it for insider trading. From my RAG, this research agent says that, hey, I think that these 30 or 24, 30, some number of X number of findings I found which have some mention of insider trading. Okay. And then I gather all this data, and the research agent gathers all this data and passes it on to the compliance agent. Now, what is the job of the compliance agent? Now, compliance agent has 2 things. It has the prompt, and it has all the findings. Now, here is where what compliance agent does is, it one by one goes through all of the findings and checks the question. And now here we're not just doing retrieval, not word by word search. Now we are checking whether or not whatever we found is actually relevant, completely relevant to the source prompt or not. And there what we do is, actually, I think we have gone through the research agent. Now we go to the compliance agent. Okay. So there, what we do is we give it three this risk ratings. We either it gives us low risk rating, medium risk rating, and high risk rating. So how relevant is this data? A low risk rating is, it means it is the compliance agent says that it is pretty relevant to the questions, which means it's good. And the higher is, it means that this is very risky. I cannot agent will never 100%. We are not expecting it to say that, hey, it is completely irrelevant, but will say high chance that it is not relevant. So then what the compliance agent does is, out of the 24, let's say it finds that about 8 or 9 of these are high risk ones, rest are low or medium. So we can filter out those high risk ones, so that we are only left with low or medium risk, which now we are pretty sure that whatever the prompt is, the findings must be relevant. And then whatever I think 15-20 documents or something that we have left with, we can pass that on to the synthesis agent. This is the final agent, and here now it already has the data. It no longer concerns with the prompt, and no longer needs to check whether or not the data is relevant or not. What it needs to do is 2 to 3 things: generate a response for us, the response that we saw, right? And generate a memo. That's all. We already have the citations from the findings. We already have the relevant data. Just go through the entire relevant data and generate a summary response, executive summary, the kind of response that we saw, and also generate the memos for those who are interested. So this is the configuration that we decided to go with, and we are pretty confident that now each and every agent is specialist in its own domain, and it doesn't need to worry about what the next person is doing, or next agent is doing, or what the agent before me did. It just need to focus on its one singular task, or in synthesis case 2 tasks, and that's it. So this is the reason why we used 3 agents. And now if we go to the 2 operating modes, as I briefly mentioned at the start. So we have, as I said, that we were building it modularly, right? Like one function at a time. So how will I be testing my UI if the RAG is not completed and the agents are not completed, or any one of these is not completed? So that's why we created a plain chat mode where we're not fetching the RAG, we're not using the research compliance synthesis agent. It is a simple, we're sending the query to the UI. The prompt, along with a lot of system prompts, is being sent to the plain chat, and that is getting returned, a response is getting returned from whatever the model that we had decided. And this is just just as a fallback. In case any of these is not ready, we can just highlight to the user that, hey, right now the RAG is disabled and you are in a plain chat mode. So this has a higher chance of hallucination as compared to the RAG mode, right? And yeah, now let me share a little bit of a code part. Will not go that much into detail. Let's see. Is my screen visible?
Yes, it is.
Yeah. So now let's see that this is the get chat model. This is what we are using in the UI. to get the chat. And this is a simple, very startup, like just to start, I added here that we are selecting a model and then we are selecting the temperature. In this case, I'm sure you guys must be aware about the temperature. The higher the temperature, the more variable the responses from the model is. And just for this specific scenario, we decided that we don't want any kind of randomness. And the open router, now open router automatically takes the response. I can show you the example environment variable. Now if we directly add the open router API key here, now the LLM will directly fetch that API key, and whatever model that we are asking it to generate, then that gets called. Now if I move to the graph, this is the basic actual crux of it. Let's see. Now the very first is the essential part is the build graph function. I'm sorry. So here we are using as we mentioned the 3 graph part, and so each and every agent here will be added as a node. Okay, see, this is a research node, this is compliance node, synthesis node, and a plain chat node. Now, if you remember the graph, from the entry to end, there were only total 4 nodes, and between those, there are what is called the edges. Okay, so now this is the start. This, if you see, I've fetched it from the langgraph.graph thing. So this identifies where the flow will start for our graph, and end determines where it will end. So now when we are generating this graph, right now you don't need to concern what the research agent is, compliance agent is. We will go into that later. But for now, just understand this, that when we start, there is only one starting point, right? And we are adding a conditional edge that if entry route, what is the entry route? It is checking the environment variable chroma ready and returning whether or not we should use rag or plain. So if the rag is ready, in that case, it routes to the research node. Otherwise, it routes to the plain node. And plain chat node. So this is our conditional edge from start we have created, and from research it is a simple edge. Now we don't need to if else nothing. Simply if the rag flow is there, then that means we are at the research agent, and there is only one route for a research agent to forward is compliance. From compliance, there is only one path forward, that is synthesis. And from synthesis, we go to the end. And similarly, plain chat. So if from here, instead of rag, we go to plain, then start to plain chat and plain chat to end. So if I show you something, so like this is just a comment. So how it works is start from, okay, yeah, good. And from here, start, plain chat, end. So these are the two paths that we have available with us, and based on the environment variable chroma ready, if this is false, then we will go to the plain chat, and if the chroma is ready, in that case, we'll go to the 3 agents. And now we can get a understanding and look at the code for the each agent. Right, let's go and check the research agent. This, in my opinion, is at the moment the most complex agent among the 3. The other ones are quite simple as compared to this. And we're not going to go line by line, but here a couple of things that I can highlight is essentially first thing. Again, I have not built this myself. I have asked this is, I think, Cursor, right? Yeah, Cursor or Antigravity. I've asked them to build the code, but what needs to happen here is I need to have a good understanding of what I want from the AI so that it will build it for me. Right? I cannot in the just write, hey, I want to do this, do whatever you think is best, and then expect it to just magically bring me a very good code. So I need to give the AI give the models very like cut to cut points what I want from it and what I don't want from it. So I did not write this code properly. What I mentioned is there should be a research agent, and that research agent should take the iterations, the max number of iterations. This is the React loop. A max number of iterations XYZ from the environment variable. I think there is somewhere. Yeah, max number of iterations. Right now we have 6, like 6 times it will iterate, and it will take the max number of iterations. There is a retriever, not graph. Yeah, there is a retriever. We have the retriever as R. What is retriever? This is the function that fetches the data from the RAG. Okay, we don't need to get much into it, but this is we provide our research agent with this capability that you can fetch the data from the RAG. If you can see r.search, retriever.search here, and this is marked as a 2. So there are particular number of iterations that we can repeat. We have a retriever. This agent has a tool which it can call, and that tool is for searching legal corpus, where it is just searching from the RAG and returning whatever citation it has. And the other thing, when I say that max iteration, what I mean by the max iteration is essentially I want it to run for those particular up to 6 times. Like first time this starts, and then I have a prompt. It fetches the data from the prompt, and then I check whether or not it is calling the tool, because without calling the tool, it cannot fetch data from the RAG. So if my research agent is not calling the tool, then there is no point in iterating further, right? So I check the whether or not the tool calls, whether or not the tool is getting called. If the tool is getting called, it means that my research agent wants to get further details from the RAG. Then I continue the loop up to 6 times. And after the 6 times, there is a hard limit. Even if there is more data from the RAG, we don't want to again and again infinitely call the research agent. So whatever data we have collected until then, I take it and pass it along to the next, which is the compliance agent. And see, all the results that we find, all the retrieved data, that is added in a result list, and then we return this as a under the retrieved, and all of this gets stored in the state graph, this one. So all my agents, they are having the access to the same knowledge. Like even let's say like from research agent we go to compliance, and from compliance right now we don't need to go back to research. But if in case we add in a functionality that where we are returning back to the research agent, it will have the similar amount of knowledge that the compliance agent has, because all of them are using a shared state called the state graph, the Nyaya state right now. This is the singular place where we are storing all the data. So like for this case, we are adding a column field called retrieved, where all the results are getting stored. Now, if we go to the compliance agent, which is the second part here. So now we have the query. We have now we can take fetch from the state whatever we stored in the retrieved right here. Right. So now based on these two, if you can see what this compliance agent does is, as we discussed previously, it will give a rating which is low, medium, or high. and then just pass the filter out the high rating part, and the low and medium it will pass to the synthesis agent. So here we have a case where we have 0 things retrieved. In that case, we just mark it as high rating and pass it forward. But yeah, here this does not have particular any tools and all. We are not even implementing a React loop here, because research agent actually benefited a lot from the tools and React loop, where here we did not find that much of a benefit. Again and again asking the agent to rate the risk, give a risk rating to the same data. So this is the system prompt that we use. You can go through this. This is also in the comment, but essentially what this is the major part, that whatever findings that we have, it must be given risk rating based on the knowledge gap that we find between low, medium, and high. Okay, and now here we expect the response, and these are a bunch of checks that to just remove all the unnecessary text and all. And somewhere here, yeah, if you see whatever the raw findings are that we are getting from the compliance agent, if the risk rating is anything but high, then we are adding it to the findings. Otherwise, we are just omitting it. And in the very end, the findings that we get, we are attaching it to the state, Nyaya state, and then passing it forward to the next agent, which will be our synthesis agent. And the synthesis agent, again, it has the same Nyaya state that we are getting. Now it has query, it has the retrieve, it has findings. It has basically all of the data that we have acquired so far. And it gives us a highest risk rating. And if the highest risk rating is high, highest risk rating is basically like, let's say that we have 10 findings, out of which about 5 were low rating, 5 were mid risk rating. So the highest risk rating in that case will be mid, and that is what it is expected. And this is just another check where if the highest risk rating is high, it means that we do not have enough data. In that case, it will just say there is not enough information to provide an accurate response, and then we will bypass, right? And now this is a section for the memo part. Here we are generating, we're fetching a lot of the, sorry, give me a second. Yeah, now here we are generating the memo, and here we are also generating this assistant message. What is the memo to assistant blurb? Now we have, we didn't really need to use, since we had the findings, we had the research, we had the highest risk, we had the citations, so we don't really need an AI to generate the memo, right? So we just generated a simple memo. This is hard coded. We don't, I mean, not hard coded, but this is procedural. We don't need AI for it. The memo is generated, and now what we are doing is the response that we see on the chat. We are generating that response using the memo that we just created. Okay, so if we go and check the memo to assistant blur, here we are just checking the context. Here is summarize the following legal compliance memo and provide a concise executive summary. So what that does is, we already have the memo generated. We are just generating a executive summary that will be presented to us in the chat. And once that is done, then we return the memo and I'm sorry, yeah, we return the memo and the assistant message here. Yeah, I got a bit confused. And this is also stored in the Nyaya graph, Nyaya state. And this graph, if we see build graph, this gets called, actually this gets called in the app. Yeah, No, we are caching it. This is not that important, but yeah, this is the app that we are fetching. Okay, this is the UI part. I'm just won't go into that much detail here, but this is where we are fetching the response, and this is where invoking, and from that we are getting the response. As you can see, return the graph.compile. So whatever response we get from there, it will be in out, and from out we are fetching the assistant message that we are displaying. And if you want, we can go into a little bit of the plain chat node. Here, this is essentially we are stripping it down with everything. We're not checking the RAG, you're not checking the findings, compliance, because there is no RAG, and we're not even implementing a loop. This is a very simple rudimentary chatting system where we are with every message we are sending a system prompt which is saying that, hey, you are an AI agent. You specifically have to mention that you are not very specific, since you're not fetching off of RAG. You are a simple LLM, and you need to be concise. So what this is doing is it will give you a slight help, but it is not that reliable. It has a high chance of hallucination. And yeah, and one other, I did give you the example for what happens. Wait, I think someone asked me what happens when there is no data in the rack, right? So let me share my screen here. I'll show you the project again, and I will ask it some random question that is really not relevant, like why are the clouds white? Now we can see, we can directly go to the conclusion that this query falls outside the scope of the provider. No remediation is possible. We can see that the scope is a mismatch. And there were, as you can see from here, there were a bunch of documents retrieved, but our compliance agent found it. Like, if we check the logs here a bit, so why are the clouds white? We evaluated the RAG. The iteration, out of the 6 iterations, we did not even, we only ran once, after which there were no more tool calls, and there were about 8 documents retrieved. You see, like even for this irrelevant data, when we are doing synonym search, there were about 8 documents retrieved, out of which compliance agent said that, hey, none of these are relevant. And then the one finding that it shared is it is the highest risk rating. As we saw, right, if there is no relevant data, we are sending to the synthesis agent one finding with the highest risk rating, which when synthesis found that, hey, I think the highest risk rate, the risk rating is high, then there is no data, and then it is just clearly telling you that, hey, this falls outside the scope, so we don't need to worry about this. And yeah, with this we wrap up the 3 agent part, and let's go over the queries and doubts if anyone has.
Kaivalya, here one thing, you have given some wrong question right now, like related to the cloud. That means internally in the RAG, this query will be pulled and it will check against some keywords, right? Like earlier, Senthil has shown judgment, some map values like judgment, order, some. Will it be compare with that one? Then it will treat as a wrong query like that? How internally it will confirm, Kaivalya?
Internally, it is confirming with the compliance agent. Right. So the job of the retrieval agent is simply to you do a keyword check, and whatever keywords that we are getting from, and fetch the data from the RAG. Now, as you saw, I showed as well, right? So even for why are the clouds white? Even for that, maybe clouds or maybe white, what keyword it picked, but there were about 8 documents that the retrieval agent thought that is even a little bit relevant, right? So this was moved forward to the compliance agent, and that is where the compliance agent said that, hey, none of these are relevant to the query. Even the query is not relevant to the legal part that we want. So this means there is lack of knowledge. And then compliance agent said that the risk rating is very high and passed that rating to the synthesis agent. And that synthesis agent saw the high risk rating and accordingly generated a response that, hey, this is out of scope. We are not concerned with this.
Okay, that means internally process, as you mentioned, one iteration has happened, like entire flow from first agent to second,
Yes.
second to third, and to Chroma and all this process, right?
Correct.
Okay. And the last question, like earlier, like Senthil has shown, right, some tokens, like it should be expiration 400. That means like something like 2000 comma 760 he shown, right? Divided by it will show around 400, something
Yes,
mentioned.
that is
That
the dimension of the whatever the chunks, yeah, whatever we have put, right? Yes.
correct. If that chunks are more, that means like whatever query, I mean, generally, whatever query we are giving, it will be break into chunks, right? That will be passed to the model, right? That means if it is small, that should be small, right? If it is small, then only response will be accurate. Is that meaning?
No, it's not like the context has to be relevant. See, the higher the thing is, it's not like you have to bombard with more information. That is how we have the similarity scores and all, right? Where the user queries, which is converted into chunks, and again it will have a vector embeddings, and that vector embeddings will be mapped against the existing chunks in the ChromoDB, and there the computation happens and see, okay, this is okay. You are asking some information which is related to this um, based on this score, similarity score.
Okay, you
So,
mean that count should be less or high? Yeah?
see, you can have, okay, see.
So, Sandeep, here is a question. I mean, whatever. So, the exact question that you asked, I mean, the 2400,
Yes,
800.
yes.
So, imagine you are asking it to Senthil. So, how Senthil processes it right now is he may not exactly process the 2400 and others. He will understand, okay, all this in his context is, or his embedding, it is related to that segment of code that he had actually explained, right? So, it is embedded to that. So it's not exactly the length of the context, it is that compression. I mean, the tokens, and there is some kind of pattern comparison that is happening with the RAG. That is, I mean, the ChromaDB or the wherever the embedding is, right? It is mapped against the embedding, and there is a cosine similarity that is being used. So, I mean, so it is not completely true to say that you have to have lower number of tokens. A lot of it is dependent on, I mean, which all tokens are relevant for the context that we have in the embedding. Senthil, I've got this right?
Oh, yes. What is it described? The relevancy is, see, assume that, okay, in this case, right, okay, so if you ask some questions related to medical terminologies, you'll not be getting the answer from here, even though you have a very huge corpus, because, so in our case, we have used a temperature of 0.1 because the legal, and we also given our system prompt, right? If the questions are out of context, we are not supposed to give the answer, which is, and we have to return it with the irrelevant ends, or say out of context, something like that. So these are some of the additional checks we do apart from what you ask. And so when you ask something related to the legal domain, see, if the similarity score is, in this case, whatever we have seen, it's 0.8 is the one which we have set the limit. But assume that if I have set a limit of 0.9, I will not be getting any output. So I have to be a little bit flexible on that. So if you give a very lower score, then you may get a lot of junk values also. So you need to define a way to determine what is the approximate similarity score and the temperature. So those two things will decide your answer relevance.
Got it. Yeah. Thank you. Thank you, Kaivan.
Okay, so the next hand that has been raised, Randhir, you have raised your hand.
Yep. Thanks, guys. That's pretty helpful. And as far technical grounds are concerned, this is good. It's a good information, like how we are going to set up the RAG. But I'm just trying to understand the end user perspective on that. Since you are getting those information from a public place, which is available for the all AI tools right now. So like whatever question I'm asking through your tool, I can ask the same question on ChatGPT or any tool and saying that okay, you can refer those information from Indian Kanun and provide me information. How your tool will be more beneficial for the end user compared to asking the same question to ChatGPT. And I'm referring that okay, just refer the Indian Kanun or penal code.
Very good and relevant question. So I'll answer this part if that's okay. So see, one of the major things that we have to look, I mean, it's not a product placement which, and this I thought I'll set it up in the context, but I'm bringing it back again. So the point of doing this development is also, do you have capabilities with you to solve problems around you? So it's not like, okay, is Nyaya agent going to completely replace ChatGPT? I don't think so, because that's a frontier model. There's a huge lot of investment, and exactly, I mean, if it says that use, I mean, not even, I mean, give the reference API or the corpus that is there. ChatGPT may do a much better job of fetching the information and providing you with the basic answer to it. The better paid your ChatGPT model is, the more refined your answer is. Okay, so that part is, I mean, that is unmistakable. So if you are looking at a product market fit, I mean, the frontier models may have actually, I mean, they may have a legal GPT, India legal GPT, that they create based on the training, and can work it out. So that part is out of question. The relevant part over here that you have to take up is, I mean, given the kind of growth of AI that is, I mean, so these guys showed you how they used anti-gravity and which was the other one? Kaivalya?
Cursor.
Cursor. So there is a suite of tools that are already available with you. And there are these open, low cost, I mean, practically zero free cost open tier models and utilities that are available. Now, given this kind of context, how can you go about solving problems with the help of Gen AI so that you get a basic grip of what to do with Gen AI? I think that is the whole rationale of these projects. So it's not like, are we creating products out of it? No, I don't think it is mature enough for a product market fit at the moment. There are better legal utilities also, like legal copywriting. I think Wordsmith has a legal utility that does a lot of these things on US context. But the fundamental of this is, are you able to take out a problem that you are facing, and with the help of utilities that are available to you, the knowledge that is available to you, and the Gen AI, which can actually do the code for you, are you able to build a Gen AI application? So that is the broad context in which I would place this. But a little more refined answer to, okay, how is it different from ChatGPT and this one? I think the more specialized your embedding is, I mean, here you are completely doing a context breakdown, I mean, context scoping over here, right? Whereas a ChatGPT, Gemini, Claude, or any DeepSeek, all those are still general purpose models. So I think that particular difference is going to help in giving better answers from here. And if we invest enough time, effort, and money, then you may see a better product coming out of this small piece of idea. Does that answer your question?
Yes, and there's a little difference or gap I'm seeing right now from my end. I may be wrong. I'm just trying to provide my input on that.
Yeah.
So the RAG system are mostly when you have a very private data and you want to use, like any company which has a private data which is not available for any AI tool, AI platform. So you have a edge over AI
Exactly.
tool.
Yeah.
In that
Randeep,
case, data
let
is
me
available in public place. Yeah.
Let me interrupt. I think there is a this is a misconception from your end that it is not specifically because this data is not available publicly. The entire point of a RAG is when you do not want your AI to fetch data or check from any other place. Right. So when you're telling me about a company documents, like, yeah, one of the very simple things is company handbooks. Let's say that I am part of a company. My company has hundreds of pages long documents, and I don't want to sit and read each and every one of those pages. So what I do is create a rack for that, and then ask my agent to simply read from that rack. So this is one of the use case. This is not exclusively the use case. So the purpose of RAG is that essentially we limit our AI to instead of reading from the entire corpus that it was trained on or something like that, we only limit it to this particular subsection of the data. It doesn't need to be private or public. And for the question that you mentioned, how is this better than directly calling the agent? That is the very first part we discussed, right? So with the agent, the complex the query is, especially for the legal and all cases, right? So there is a high chance of hallucination, and you don't want hallucination when it comes to legal, financial, or medical fields. So it is better that the agent directly says, hey, I don't have enough knowledge to tell you about this, than to simply hallucinate. And so here what we are doing is the main aim is to whatever data that the AI is returning, this has to be correct. And now second part is this relevant or not? That is what the compliance agent and all of this is. But we can be certain here that, hey, we're not pulling anything out of, like, now tell me, whatever agents that they're like that are getting trained on Chinese data or American data, how sure are you that they will be knowing about the laws of India? How
Well,
sure are
that's
you
true.
that they will?
I won't take much time because I think let other people talk about that and ask questions. I will say like there are options like prompt engineering where you can provide the pre-context about what your questions to the tool and they can answer you. And I believe the data for Indian Kanuns are available public, but I think let other people ask their questions. I got the answer.
Yeah, let's move on to the next question then.
Yeah, I think the next person is BS Sai Verma.
Yeah, hi. Hi. First of all, great session. Thanks for this. And I have a question on like the validation of the entire pipeline. Once you build it, what kind of metrics did you validate it on, and do you have any numbers to show? Like,
Yeah, for the evaluation part, I think that's what you're saying, right? For
yes.
evaluating the RAG pipeline, yeah, that part, that is the third pillar that we'll be discussing after this.
Okay.
And unfortunately, we are not able to give you the live demo of running the evaluation because again, it takes a lot of time,
Yeah.
which we simply do not have right now. We're already running out of time as it is.
Yeah.
But yeah,
And-
we'll go through that
Yeah.
next.
And more technical question, say, like, will this tool be up to date on anything that is getting published recently? Maybe there's a law that prohibits something a few years ago, and put it in your RAG database, but now that law is changed, and today I want to research on it. What's the guarantee that it is still, it is relying on the latest data rather than something that's there in the pipeline? Like, how is that weightage calculated?
This is there is currently no check for that. Like whenever we are creating the latest RAG, the knowledge cutoff is at that point. Like for now, 2 months ago, I think we created the RAG, at least in my local, that is deployed. That knowledge cutoff was 2 months ago, and whatever data we stored then, it is still we're fetching that. It is similar to the LLMs, right? So If an LLM was trained in 2023, so whatever it is after 2023, that LLM will have no idea. So what they do to bypass this is they just add a tool. So like if I'm asking anything about 2025 or 2026, the LLM identifies that and then directly does a Google search. And we can actually implement that like this, since this is just an MVP. But this is a good point. We can, for future versions, for future changes, we can add some place where it can also figure out that this is part of the data that I do not have, and add it in the to do where, hey, next time when we are doing, we need to add this. But still, a human element, we're limiting this part because a human element needs to be there at least while preparing the RAG, so that we are confident that the entire database is correct.
Okay. Yeah, like I'm building something similar, and that's the point where I'm stuck. Like, can I just plug in a web search tool or skill to it and, like see if there's anything relevant apart
Yeah,
from the database?
yeah. Based on how risky the project is, like if you're just simply doing some where even if the responses are sometimes a bit inaccurate, it is fine, not that big of a loss. You can directly add a web search.
Okay, that helps. Thanks.
Okay, there are few more hand raises. Let me ask the team to, because there is one final section we have to go through, which is the evals. Kaivalya, that is the final section, right?
Yeah,
so we'll get through the evals and then we will open it up for questions. I hope that's all right with all of you.
Yeah. In the meantime, you can drop your questions in the chat. I can respond there. Okay.
Okay. So let's continue. So all those who have done your hand raises, you can keep your hand raised, because after the session we'll come to you and take you in that order. Okay. Yeah, Kaivalya, you can continue.
Yeah. Aditya?
Yeah.
Do you want me to share, or you are sharing?
Yeah, I think I can share.
Sure.
So just to confirm, I'm audible, right? And let me share my screen as well. Please let me know once it is visible.
Yeah, it's visible.
Yeah, thanks. Okay, so just to in interest of time, I will just quickly go through this slide. So for example, it covers the session memory. So for example, whenever a user start chatting with her model, right, there is a session generated. So let's say we will have one URL which will persist all the data for that particular session. So you will be seeing it like this. So let's say once you deploy it, so there is one session ID which will be here, and another user can use the same session to continue the chatting and all. And we have kept it as a rolling context window. It means like just to keep the things fresh in memo and summary, right? What we are doing is we are just taking 6 user message and LLM responses, summarizing it there just to not flood the context window and all. And another thing is just like our uh, just like we have the UI setup, we have a CLI file as well. So I hope when I'm switching in between, the screen is visible. So basically, you can go through after the session. So there is this run Nyaya, which is a command line utility. As such, you can just query the LLM responses from there. So moving toward the so yeah, before moving to the next part, I can quickly walk through the front end code that we have there, and after that we can jump to the RAG evaluation part using RAGAS framework that we have. So for our Streamlit app, basically first we got all the necessary importings done, for example JSON, UID, warnings and all. After that, we load the environment variables. So after that, we will import the required functions from graph memory and evaluation drag and settings as described by Kevin earlier, all the functions which are here. After that, we will set up the loggers. So on the right hand side, you must have seen the screen. So we will be logging the responses at each step, what happened and all. And there are the different functions that we have there. So for example, to generate a PDF, right, from the memo that we got along with the citations and all, we will be having it in this format. So for example, page size is A4, body format is this, these are the tags and all, and we will just provide the content. And this bytes input output, it is nothing but used to get the PDF bytes and store it there as a PDF. This is for the session ID. So each session will have a unique session ID, so they can use the same on a different desktop or like another client, let's say. In the main, we will just like whenever our app start, we will get the session ID, we will set up the context variable as such, and we will set the path. For example, you will be seeing the things on left, right? So I think someone asked how we are determining if we are using a agent or if we are using a RAG, right, to answer the question. So basically, we have this chroma ready flag. So if our vector DB is ready, so we can just set it to true in environment, and it will use the agent framework. Otherwise, it will use the LLM. So it is basically a simple Streamlit UI where we have the front end created, and this is the toggle button for the memo, so you can see it. So in the interest of time, I will not able to show that, but yeah, this is for the PDF storage. So whenever a user clicks on that button, we will just call the function and get the PDF created accordingly. Then another important thing, it was regarding the RAG framework, RAG validation framework that we have. So just to benchmark the responses that we got from the created vector DB, and if it is being giving the correct response or not, and to ensure the quality of the response that is being returned, right? So we have used the RAGS framework. So before going deeply into the RAGS framework, I would like to tell you the meta process or like the first principle kind of thing that we earlier decided to go through. So for example, let's say why we are using the RAGS framework, and why not a simple let's say word matching or like a substring kind of thing where we will match the return output from LLM with our ground truth. So basically, for the validation and evaluation part, there are two things. One is the response returned by the LLM by using the vector DB, and another is the ground truth. So in ground truth, it means like the static factual thing that we have. So let's say there are a couple of traditional text matching models like Rogue and Blue, which can be used. So at the earlier stages, someone can ask a question like why we went with RAGS and not with the text matching algorithms or the models. So to answer that, so there is a term called the context and the what should I say, like the meaning of the response which is written by the LLM. So let's say if our ground truth, it says the penalty is a fine. So let's say 100 rupees or 200 rupees, something like that. So let's say our ground truth says we have a penalty which is a fine, and our LLM will return a response saying it is, let's say, a court decision to impose monetary sanction for that particular case. So if we see, like, meaning is kind of same, we have to pay the fee. So as we are able to determine, the LLMs should so like we are using the RAGS framework as a model to determine the same thing. So let's say if we are using a traditional text matching thing, so it will not capture the essence of the ground truth and response which is returned. So that was like the first thing we kind of decided, and after that we went with this framework. So it is nothing but LLM as a judge. I can simultaneously show the code part as well, just to refer the things we have implemented. So for example, we have like used precision recall and F1 score to get the evaluation done, and we have converted it into a 5-star rating just for like simplicity kind of thing. I think for our case it lies in between like 3.5 to 4 out of 5. So that is one thing. Moving to the next slide. So let's say if we want to do a evaluation, right? So these are the things which we need to be aware of. So for example, the precision rate, so it is like the kind of accuracy thing on which we were able to, or like our LLM was able to get the chunks on the particular topic. And recall is nothing but like whatever the data positive things that it was able to find for the document. So it kind of denotes the relevancy of that topic. And we have the F1 score. So people from mathematics background, it is nothing but a simple harmonic mean that we use as a F1 score, and we will like convert it in 5-star rating, averaging it out. So how it runs? So basically we will have a couple of questions. So let me also share the evaluation RAG pipeline as such. So if you see, we will import the data set, import the retrieval agent, import the LLM, then the Hugging Face model and all. And we have the different function from this RAG. So evaluate, then precision recall, then the wrapper. And here if you see, these are the questions, let's say, that we kind of use to evaluate the RAG model that we have implemented. So for example, questions like what is, so there are different domains, right, in legal corpus that we have. So just to evaluate the questions, we have kind of like took these. So it is not a hard and fast rule. We can also like add multiple questions to it and get multiple ground truths. But for the evaluation parts, we are running multiple cycles for each question to make sure the accuracy is correct. And it takes time to evaluation part. So for example, these are the 3 questions, and according to the question, these are the 3 ground truths. So what we do is we just ask this particular question to our LLM model. We will first like embed it, and we are using this in legal BERT model from Hugging Face. So yeah, so basically we will provide the question along with the context. So as a user context, we will capture the response from the embedding model or a RAG, let's say. And for each, we will try to see like how relevant it kind of gave the result according to our ground truth. And excuse me, so sorry, for each question there are a couple of rounds we can determine. So let's say if we want to get the things done thrice, so let's say for each question we want to ask it thrice to the model. So here we can define that number. And for each question, actually it will retrieve so the previous function from another module, I guess it will be there. So we are just calculating the hits, we are appending it to the context, then we are creating these samples which we will provide to the particular LLM Ragus framework that we have. So the user input questions, then references we will provide as a ground truth, then the retrieve context and the response. So for each question we will run this loop, and let's say I think we have so let's say if we are not able to run this function, there is this import error. So this will only run the loop once, so the validation can be also changed. So basically in both cases, what we are doing is we are just calculating the returned results. We are calculating the precision, we are calculating the recall for that, and we are storing it as a F1 score and appending it to the round score. And basically, let's say when our loop runs for each question, we will be storing the F1 score. So we are just checking with the rounded score and with the base score written by the F1 score for each question, let's say. And for overall score, we are just taking an average and converting it as a 5-star rating. So let's say if our model will return 1 out of 5 or 4 out of 5, like that we are returning the ratings back. In the import error, it is nothing but the same thing that we run above, but it only runs one time. And yeah, so this compute rating, it is nothing but for each precision and recall, we will calculate the F1 score. We will get the average out of it and return it to the main function from where it is called. So basically, just to give a overview, it can be a good framework to get the evaluation of your model, how accurate it is. Let's say if the accuracy is low, so you can maybe try to increase the corpus or a domain from the data ingestion part that we do at the first part. And another thing would be the question relevance according to the domain. So just to quickly summarize, we will have the questions, we will retrieve the data from ChromaDB, we will have the ground truth ready for each questions that we have. Then we will calculate the precision and recall. We will have a harmonized mean, that is the F1 score, and it will return a 5-star rating as a result back. So I think that covers the evaluation part. So this would be the end-to-end query workflow. So not only related to Ragus, but the overall stages, I should call, for our pipeline. So when user submits a natural language question in chat, we will just route the query accordingly. So it means like if we want to go ahead with the agent part, or if we want to go ahead with a LLM part as a response, so that will be determined. Then the research agent will run, that will get the relevant chunks out of it. Then we have the compliance agent, which is described by Cavallia. So after that, synthesis agent will run, which will generate all the things, memo and the summary of the response written by the LLM. And after that, we will just provide the result, and there is this session which is preserved for that particular user. So I believe that was one end-to-end cycle. Maybe Cavalier Senthil, if you want to go ahead with the workshop concepts that we applied during our journey.
Yeah, sure. Let me share my screen. We can go through this quickly. Let's see.
Yeah, let me stop sharing.
Is my screen visible?
Yeah.
Yeah. So I don't think we need to spend a lot of time on this, but this is specifically like we just wanted to share our experience with the workshop. Like there were, I think, in total 6 sessions, and how each and every session helped us in developing this project. Like while we don't actually have to say that each and every session directly helped us. That is not necessary, but each session contributed towards that our experience, so that we are well equipped to get better understanding. Like even if these workshop sessions, let's say that they were able to give me 10%, 15-20% of the knowledge of the field, then rest of it, at least I know where to start. Like for example, the session 1 and 2, these were for basically what Gen AI is, what are the fundamentals, and these and all. These were specifically for just to create the grounds, like to understand what LLM is. When you're saying tokens, when we are saying prompt, when we are saying that what are system prompts, what are user prompts, all of these things. So when I'm going online and when I'm trying to understand the in detail, I'm not getting overwhelmed. Like it's very common that when I'm studying something, I want to research something, and then in the very first line there are 8 different things that I'm reading for the very first time. I don't understand, and that kind of sometimes overwhelms you. But here, what of the first 2 session specifically did was that they prepared the groundwork for us, so that even after that, if we are wanting to go out and get a better understanding of our own, then we can do that. So like specifically, if I highlight to the session 5, so the Ragas framework, that is something that we on ourselves came up with. I mean, not came up with, but figured out. We found about it, we researched about it, then we implemented it. That was not covered in any of the session, but based on the discussions about evaluations, based on the discussion about how we need to understand and identify that the RAG should be evaluated and all, and along with the mentorship sessions for the project, they gave us the understanding of why we need to evaluate, how we should evaluate, etc., so that we were well equipped to do our own research and come up with the library. And for the 6, for the session 6, there was an MCP part, but that is currently not a part of our project. And in future, maybe we can implement this, but at least for the initial few versions, even if we plan to upgrade it, it is a bit of a lower priority. But yeah, again, but that is what was discussed on the workshop, and then it is in our mind. So like we intentionally chose not to implement that. Unlike if we were not even aware, then what the case would have been is that we're not even aware, so we don't even know whether or not it would have been useful for our case. In this case, we were knowledgeable, and we intentionally chose that, hey, we are aware what an MCP is and what everything is, and we chose to include these parts, we chose to exclude those parts. And this is also particular. This is a little bit of peek inside of for the at the time of ideation process. Like we chose to go with the Indian Kanun, which is returning us JSON format, returning responses in JSON format. Along with this, we had a bunch of other sources which we could have used, and we can also use for future purposes if we need. Something like SEBI RBI circulars. These are semi-structured PDFs, and if need be, we can use something called BM25 to store that. And Gazette of India, that is also a thing that is completely unstructured PDFs. And we can use Neo4j graphs to store this. So like this is just to give you an example that there is not one particular source. There are multiple sources. There are multiple different kind of responses. Like we got JSON response. That's not necessary. So each and every kind of response will have its own different type of method to be stored, to be fetched, everything. Just we decided to go with Indian Kanun API, and yeah. And for this is a little bit in depth about each and every session. And with this, I think we can wrap up the session from our end. And yeah, I hand over to JK if you're available. Hello, JK.
Yeah, you are audible, Kaivalya.
Hey, hi. Sorry. Am I audible?
Yeah.
Okay. Yeah, so I think there were a couple of questions that we had to take up. I think the first is, so we'll quickly wrap it up. It's already 1:25. So in the interest of time, we will take these two sessions. But before taking up this questions, I have just a couple of pointers for everyone. Based on all the inputs that you guys gave in the last session, something that we have done on top of it is, okay, let me just bring it on here. Yeah. I'm just sharing my screen so that it is visible. Is it? Yep. Yeah, so I'll just take you through this particular workshop companion resource. So this is a companion resource that we have built around all these sessions. So if you are, I mean, based on where you are, we have given you some pointers as to what you should start off with. What is there in the repo? There are session recaps, slides, links, and other things. So for each session, there is a inside the sessions folder, you will have the respective links and other details. Something in terms of resources that we have done. So we have also put up some good resources that at least we trust. So that's what we have done over here. So these resources are available. There are courses. The more our preference would be you refer to most of these more recent things like the Substack articles and podcasts, because that will always have the latest information coming up. And in podcasts, there are like multiple podcasts that we have given, No Priors and Practical AI. These are two very low floor podcasts that people can actually listen to and have a basic understanding. In terms of websites, there are a lot of websites that are available, but what we have done over here is at least where these models, data sets, etc. are free, those we have put it over there. The Open Router model catalog, Hugging Face, prompt engineering guide, the Ragas documentation, LangChain and LangGraph docs, Google AI Studio. These are all things that you can look at. Something more, bit more, let's say if you are trying to do a lot more of decision, we have something called cost heuristics based on token. So this is as on 11th July 2026. It's not, let me also say the cutoff period. So this is how the calculations happen, and rough heuristic that you can use while you are developing your own Gen AI application. These are basically based on multiple of our own experiences. There is a model decision matrix that we have come up with, what to use, when to use. Again, these are based, some of it is more of personal preferences. We have looked at multiple. So during this entire Gen AI workshop and other Gen AI use cases, we see how people are using it, and we get a feedback from students. So what you see here over as cross is these are very much of paid solutions. It's not a free solution. But the key thing over here is this is the segment that these 2 points are the key things that you will have to do at the extraction step. So it's the step that is important, not the entire app. So the extraction step, you should use a very cheap and fast model, and it is the final reasoning step. You will have to use the Geminis, OpenAIs, Claudes, and other things. So that you will have a mix of models over there. And the escalation ladder, typically when you are doing a hobby development and others, is use free tier and flash class models first, because that's the cheapest model that you can work with, like what Nyai team showed. I mean, most of it was using very free tier, and develop a simple POC before moving on to mid tier or frontier models. Okay. So mid-tier models are the lower, I mean, slightly better price. So for example, Claude Sonnet is I would call now it is a mid-tier model, whereas a Opus 4.8 or Fable is a high-end frontier model. So escalate only on measured failure, as in, so use this escalation if you see certain failures happening. Otherwise, I think developing with free tier to get a grip on what GenAI is good. There are these models, scorecards and others. If you are really interested, yes, that will give you a little bit of things. But again, we are seeing a lot of reports that SW, Workbench, etc. are slightly wrong models. I mean, are giving wrong scores. Fable has been mentioning that. And the most important thing is free tier is for learning and it is not for production. So a lot of free tier development happens more as a learning process for you. Once you have that, then I mean, if somebody is able to fund you, or you find a source of using these kind of models, that's when you go for production deployment of actual use cases. Okay. Some basic things where we found credit card is not required. Google AI Studio, I've heard both responses. At least when I tried, it didn't ask me for a credit card information. So I'm hoping that it is how that is how Google AI Studio will be on the coming days as well. But yeah, you can try doing that. But yeah, generally this is like a workshop companion resource that you can use. This is a free repo. We are also trying to build a small app around it. This app will also be shared. It will take some time. We are doing some amount of testing. Once that testing is done, that app will also be released later today. So you can actually see some of these resources. This app will be available for 2 more weeks to learn. After that, you can come back and learn from this public repo. This repo is forever free. Some of it is GPL, which means you have to share it as is. Some of it has MIT license. So the licenses are also explained in that. So yeah, so that's pretty much it. Now I'll have the 2 questions, ND and Srikumar, in that order. So
Sir, I have just one question. So just one question. So the thing is, I have seen in industries, I'm not just saying, sir, I'm directly to you. The thing is, we have seen in industry, everyone is selling the courses completely, like, sir, 1,000, 2,000 courses. Some of them on YouTube, 9 rupees courses. These are the courses. So we are stuck in this loop. We will do the courses, and we are not focusing on developing our muscle memory to build something from scratch, whether it is a little bit small or little bit medium. So we want something where we can develop something, or we can do the hand dirty in a code to develop something, to showcase something, rather than just stuck in doing the courses, getting the certification, uploading on LinkedIn, and just trying to clear the interviews. That's my point. So just wanted to be something where we can get some small tasks, and then we can complete that tasks, and then we come back, and someone who can say, yeah, you will get this point, something like that. So we just want, like, still we are in school. we can say like something jahan pe we can get reward or something like that on our
No,
project.
so Utkarsh, so that is what I said. I mean, see, so the whole point of this workshop is also that. I mean, we are also seeing a lot of people going behind courses. So the model that IIT Madras had applied for their own students is take one use case from your own environment where you want a problem to be solved. So if you look at look at the app that was created last week, I mean, we demonstrated last week, it was a genuine problem that came out from the user's context, right? I mean, he had multiple health devices, health data available. He wanted to make sure that there is a way to do this in a what do you say, in a way, there is a way in which he can collate all these things and he gets some useful information out of that. So that was the problem statement that was taken. So the biggest teacher for you is your own experience. I mean, the failures that you make, that is the biggest teacher for you. So over there, and what we are showcasing to you is, okay, I mean, you may not know the entire aspects of coding and other things, but there are these utilities that are available. So throughout this workshop, there are 3 different use cases that we showcase to you. So in the first case, we followed the methodology followed was, okay, before I start developing any app, I will make sure that my problem case is very well specified, right? So that was the methodology, and based on that, each of those segments were separately coded with the help of AI. So that is one way of doing it. Now, if you come to the Nyaya agent use case, there was this genuine use case. Okay, there are these lot of legal precedents out there. How do I make it useful for me? So that was the problem statement. And over here, instead of, okay, I think, yeah, this is the kind of solution that I want to build. Let me break it down into small blocks. So rather than a problem statement breakdown, the solutioning will be of this nature, and hence let me break down that entire system into these things. So I have to have a repository knowledge, that is the RAG, where the entire Indian cases and other things are built around. And I now have 3 agents that will work on top of it, handle the query, and provide a response back. So that is what Nyaya agent has done. Now you will see another use case where it is talking about, I have a lot of skill sets, but how do I make, how do I understand what are my learning gaps and how do I go about it? So there is a little bit more stricter eval and RAG kind of things that they will also talk about. And all these came from the same set of materials. All those materials are publicly available. So I gave the workshop link last time. Maybe I'll put it in the common repository also. So to answer your larger question, okay, is there a single course which will cover that entire thing? Maybe there, but I'm not sure where it is. Even I am in the search of it. But all these, what you see, are experiences that even I have been doing. So over the last 1 year, so typically how you bring your muscle memory is, so the first step is you should have a regular chat with AI. So I'll take my example. So I have been on a Claude Pro subscription for during entire 2025. So 2025 Jan to 2026 February, I was on a Claude Pro subscription because free tier subscriptions do not have that much of intelligence, and I needed to understand how LLM responds. And at that point of time, my work, the scope of my work, it was multiple kind of things to be done. So it had certain amount of coding, certain amount of general reasoning, certain amount of documentation. So there Claude fit the bill. Okay, so I mean, I found Claude. I mean, it is more of a personal choice. I mean, this thing would have been better. OpenAI might have been better choice, but I selected Claude as a first case scenario, and I understood all the different aspects of Claude, projects, tools, skills. All these I understood by using it on a daily basis. So that's what muscle memory is, right? And once you have that particular thing, then you go on to the slightly more advanced kind of frontier thing where you actually do download an agent harness, Claude Code in this case. If it is GPT, it could be Codex. Gemini, it is anti-gravity. So a lot of these kind of solutions are available, which actually helps you build a complete solutions, a coding solution, so to speak. So these kind of things, and it is not just talking over there. I have been subscribing to a lot of Substack articles, so I read them on a daily basis to understand. Then there are a lot of podcasts that I listen to, so that I'm able to understand where the industry is headed and and these have to be trusted podcasts. So it is not an arbitrary podcast or an arbitrary website that you will listen to, and there are tons of it. There are a lot of websites and podcasts and other things, but I look at, okay, what people in my circle or people whom I trust are recommending. So that becomes a what do you say, a use case that I will explore further. And if certain websites it has gone way over my head, so I have stopped subscribing to those. But certain things which are relevant for me, so for example, Simon Willison's blog or web blogs, that is something that I am daily consuming, because he's very up to date with LLMs, the capabilities of LLM, what are the ways in which it can be exploited. So Simon Willison is a power user. So there are power users, there are these regular normal users, etc., whose blogs I refer to, and that gives me that. So there is a lot of hard work which is easy for, which is not available in a course material per se. It is very difficult to synthesize all of this in a single course. So the way to do it is, once you start with a problem statement of your own, that's when you will figure out, okay, it failed at a particular point of time. Now, how do I solve this? That's when you start looking into other solutions, right? So we have seen that this taking use case from your context and then building on it as a much more better course work than going to a course, learning and then doing. So that's one part that we have been consistently doing in our sessions. And if you look at the workshop sessions that let's say Bharat has been talking about, what Kaivalya and team has been talking about, it is modeled in that particular nature. So there are some basics that we teach them, then we show certain use cases, then we ask them to take a problem from their context and build. And whenever they are building, our mentors, the workshop mentors will they will review it with the mentors. Mentors will provide some suggestions, and then according to that, they will further develop it. So whatever you are seeing over here is a completely implemented app for the workshop setting. It's a completely, you have a safety net. There is no market where they have to take that app out to, right? So it is a completely big safety net where they can fail, they can redo, all these possibilities are there. So that's what we, and that's a formula that has worked well, at least in the last 6 months, for at least 30-40 of our cohorts. So when I say cohorts, teams, that's what we have seen. The Gen AI workshop details are provided in the chat, and I'll just share this again, the GitHub URL of the workshop companion in the chat. 1 minute. So this will give you a little bit more insight and understanding on what the session is about. Utkarsh, does this address your question?
Yes, sir. Yeah.
Okay.
Actually, Krishna, just to add to Utkarsh's point, like let's say if we So you mentioned like we need to do samples in the real time, what basing upon that one, right? But if but day by day the technologies are going, like it's increasing, right? Like so for example, deep learning, neural networks. Now, how to link it? Like for this use case, what neural networks? I actually I am not aware of neural network. Like does it exactly fit to that my use case, or do I need to go with that model, that library, or TensorFlow, these PyTorch, and number of libraries are there, right?
Yeah. No, so see, for that, I think, for that, you will need a little bit of prereq in ML practices. So an ML practice course is what you would need rather than because a lot of how and why comes from a more foundational, more academic courses what you would require than a skill course. Now, typically of skill courses, and this is something that I have seen over the last 4 or 5 years. It doesn't matter whether the models progress or let's say the technology itself change. I mean, when we started, I mean, and the program, the IIT Madras BS program, data science was a craze. Then everyone was talking about PyTorch, RNNs, CNNs. I mean, deep learning. These were all the big hits at that point of time, and we were developing courses around it, and we were focusing on the fundamental ideas behind all these things. I mean, what happens internally, and what we have seen while developing assessments for students is this case that even though the technology or the model changes, the fundamental approach in many of these are not changing. So, for example, let's take the ML model case. I mean, so let's imagine you have to predict. So in our case, it is about, I mean, I have students who do multiple courses term after term. And I have to predict, okay, how many of them are going to come to the diploma level or wherever. Okay, I have to predict churn. These are all standard questions, and the way the point of that is, I mean, there are these multiple models that are always available, but sometimes simple regression models, simple SVD, etc., which are more foundational things, right? I mean, what does SVD, the fundamental thing, do? If you understand that, then what you will understand that is this extension models, etc., which are very niche and maybe more relevant to a specific use case. You could reach that point from this fundamental understanding of SVD, linear regression, etc., and you can extend it further, and mix it with other ideas and reach up to that. But the point is, you have to start somewhere, and the safer way to start is where more available knowledge and which is more foundational, right? So the moment you are starting at a foundational place, it is easier to then build on top of it. All you have to then do is follow the process of take, develop, fail, iterate. Take, develop. This thing continues. So this we have seen a lot happening in our, I mean, what do you say, academic curriculum setting and corresponding project. So for every academic course like these, we also have a skill developing project associated with. So when we take problem statements and others, what we have seen is simple regression, starting with simple regression models. If they build on top of that, automatically they will reach the optimum model. Same case for application development also. I mean, there are these base technologies, I mean, subsystems that you have to be really aware of. Once you know the subsystem, then you can build on top of it and reach that final whole application through newer technologies as well. So these are some things that we have seen, at least after failing multiple times. So we tried to develop the best project statement, problem statement, etc., then try to induce it to students. That didn't work. So nowadays it's a more practical approach. Okay, give them the boilerplate template, and then from there incrementally develop them towards the more complicated scenario. So that works much better. And the good thing about that is, even though there is increments happening, because the foundation is the strongest part where we are focusing on, it doesn't matter whether what is happening is the models are changing and the way models are being utilized is changed. So if you understand where to use models, The only thing that you have to add on top of it is, okay, now what kind of model should I add over here? Should I add a reasoning model? Should I do a slightly more advanced reasoning model, or the basic reasoning ones? These are the decisions which you have to take, and these are much less impactful heuristic in a learning setting, but it will have a lot of impact in a production setting because cost and other things are associated with it. Okay, this, I know I spoke a lot. Was it making sense?
Yeah, got it. Like we should be aware of get confident on the base models.
Yeah. The base is what, and that base has to be strengthened really well. So how do you do it? Because nowadays coding is becoming more like how better can you think and speak English. That's how. That's a very crude analogy that I can bring in. The better your English is, the better your code is. So the more unambiguous and others you become, the better your application will be. Yeah.
Thank you, Jagdish.
Yeah. ND, you have a question?
Yes. So, Professor, I don't know whether I'll get chance or not, but your passion for teaching and explaining, is very clearly visible. The way you explain, even after the session gets stretched all the time. Last time also it took until 2. This time also, it is. And then really kudos to the entire team, Kaivalya, Aditya, Senthil and all, for in detail explaining everything and patiently answering all our questions, ranging into everything, right? So really appreciate that. It was very, very delightful and very learning experience. So I have a basic question, 2 questions basically. What is the need for evals? Like, deeply, something can be explained around that, number 1. And number 2, these sub-agents that that were there, and what does qualify them as an agent? Are we calling some models, LLMs or some other models, behind the scene for that? I saw system prompts in some cases. So are we calling those models, then, what is the qualifying criteria for, picking some of those models? If, in brief, something like that can be explained.
Okay. So there were 2 questions that you had. One was on evals. So let me answer the evals part. Now, evals is the one which drives the quality of your application. Now, any application, it will generate an output. Is that output a legit one? Did it hallucinate? So you need to, so typically what happens is there is some sampling. Typical evals, what it does is it does a sampling of it, sampling of the output that gets generated. It runs it through. So there are multiple evaluation strategies, but think of it in this case, in the case that Kaivalya and team was explaining, given a particular thing that Nyaya agent generates, now what you do is ask a advocate, okay, what will you do in the same? Explain the context in the same scenario and get the output that the advocate says. Compare these 2, and then in certain either compare these 2 or ask the advocate to look at this and point out missing pieces or some things that it has done better. So this process is evals. And now when I explain this, you should understand now this is the most critical part of it. Without evals, the credibility on the AI output is much less. Even though it may give you a flowery language thing, you will not be able to take it completely to use in your own use case and apply. So that's why evals are important. Evals are a complete segment in itself, and it's really hard to compress everything in the 3-hour time duration. But we hope in the next session, we'll cover a little bit more on evals specifically. Now, coming to the second part of this one, agent. So agent model. So, so see, some things that you have to understand is this entire field. So if I'm assuming that you have seen how software engineering evolved from the original SPLC to
20 plus years, sir. Yes.
Yeah, the
exactly.
Scrum practices.
Yeah.
Then you have very specific engineering practices built out. So earlier it was okay. There was only a subject matter expert who gives the spec
Waterfall,
to the
yeah.
developers.
Earlier it was
Developers had
waterfall.
their own individual run, then their unit test, etc. that they do. Then there is a QC team. So there was the very different life cycle and different kind of composition over there. It has changed to more like, so now a developer has to do testing also. So it is expected that the developer will do the testing as well. And then there is a DevOps. So instead of a separate team to push this to production, there is a DevOps who understands the developer this thing, the GitHub repo. There is a continuous integration and continuous deployment cycle that they build through which applications move to development. So what is happening is a lot of these things are actually evolving. But the fundamental, so again, why I'm going back to fundamentals is, at the end of the day, there is a problem to be solved. There is a way to solve it, a code or a tool that you can use to solve it. There is a validation of this, whether the tool solved the problem. And there is a deployment of a solution for the consumer to use. So this is what essentially an application is. Now, over here, when it comes to an agentic development, and this is, you may call it as a very coarse analogy, but think of it as an entire very big bus, a big motor vehicle. So agents are basically multiple drivers or controllers who are sitting around it. And maybe I'll call it as a flight. So you have a lot of knobs and other things that are around it, which in turn runs some internal mechanisms, right? So these mechanisms are nothing but tools. So tools are nothing but loops, continuous loops, and some specific function that each of them has to do. So for example, I have to write a markdown document. So there is a skill. Markdown is in this format. Words are written like this. Hash means title. Hash means H1, right? Or some kind of rules and other things are there which is associated with that. So it's a skill. So when there are multiple skills involved and a task has to be done in loop, that's where an agent comes in. And an agent will be provided with some kind of framework and boundaries that they cannot cross. I mean, that is the best agent design. So there will be, so in this particular flight, there are multiple agents over there which does that. And in some sense, the fuel which powers the entire thrust and other things, that's what LLM. LLM's output is, LLM is only like a source from where it gets the fuel. So imagine it's like a fuel tank, right? There is a certain set of fuel, but there is a processing that happens, and that is taken in, and it is, it may be sprayed and combustion happens, etc. So those kind of things will happen. So you have to think of each of these as these individual pieces which work together. An agent is a thing that coordinates this entire process. When to send a call to LLM, when to use a specific tool, when to just don't do anything. All this is done by the agent. So that is the definition of
within the boundary.
Yeah, within the boundary that the developer has defined.
Through
and if the developer has not defined the boundaries well, then the flight is going to crash or do turbulences more. So that's the way you have to look at it. And it's analogy because the term agent also is getting evolved. So earlier we used to hear about prompt engineering. Then prompt engineering gave way to context engineering. Now it is harness engineering. So there are a lot of terminologies that are changing day in, day after. But I think the fundamental of it is, what are these? These are all specific aids within which helps the flight to fly, right? Now, where do you want to name it? How do you want to name it? It depends on the function.
Correct. But there is, they are autonomous. Like, within that boundary, they are able to, there is no fixed algo. They are able to work in a varied inputs and output. Right?
Tools and loops are deterministic, but agents can provide non-deterministic output.
Okay. All right, and that's where there are probably each of these agents, they are using some model behind the scene to work.
Yeah. So they will make calls to the respective models to get a specific set of output.
Okay. All right. Thank you.
Okay, Sri Kumar, you have a question?
Yeah, thank you. I got this last chat. I think maybe okay, fine. So thank you, team. Especially JK, thank you. You guys are doing very awesome work, and the level was so high comparing to the previous one. And JK, it's a long time seeing you after a long time. Maybe we are the friends. You may not be remembering. We are in the Fizat.
Oh, okay. So that's why VG Sri Kumar is very familiar.
Correct. So it's very good. My son is also watching the same. Okay, very good. Thank you on that. So
okay, by the way, he was my batchmate. So you are not allowed to ask difficult questions to me.
So I have a very simple question and it's already answered, but I was just thinking. So in that Killian was telling, right? So we have that in the workflow. It was it will go into the rack part or it was a plain text, and that switching is based on the environment variable, whether the chroma DB is enabled or not. But that is moreover a manual task, right? I mean, we can when the chroma DB is always definitely we will add the data to that vector database, right? So then it will be always that path only, right? What is
No,
the
it depends. It depends. So imagine that we are doing a boot up without any context, Sri Kumar. So at that case, we want to really see whether something of that context is available worth taking. And at that point, if we see that the chroma DB is, it is not available, then I will directly put it to my LLM. So I'm not talking from an embedding perspective, but I may want to bootstrap it from some initial knowledge. So think of that scenario.
Init containers, it will be just starting that path.
Yeah. Otherwise, most of the time we would want to use chroma DB because I want to reduce my LLM cost. I don't want to always get my answers from LLM, right? It's only a polish that I have to do.
One more. I have that. So how you will make sure that there is no drifting is happening to this model and all? What is the method to fix that?
Yeah, so the drift, I think a lot will depend on how you do the evals. Set up the evals, right? So if the outputs are okay, so the cleanest way and the way we have seen in other applications is the drift is controlled by the guardrails and the evals put together. So it's a combination of guardrails and evals. We still see that certain models still jump out of the guardrail, but then if the eval pipeline, if it is caught in the eval pipeline, then that helps in reducing the model drift. But yeah, it is not so straightforward in a hobby app. It is more of it's a more of a production grade app where we can really test it out and bring this under control.
So what I take it up, like you need to continuously go with this eval process and
yes. So there is a sampling. So what typically happens in a production grade application is there is so we basically dog feed it, right? In our use case, a lot of it is dog feeding because we use our own evaluation. Our own use cases to consider evaluation. So so maybe some 50 turns we take. Let's say it has been used for some 500. We use 50. So some 10% rule is taken. And that is used for eval. And we look at, okay, what would have been better? What if it was sent to another model? What if it was sent to, what if it was a human rater who evaluates it, right? So these kind of evaluation processes are there. Human evaluation is used only very rarely these days because it is very, in terms of time, it is very costly. Usually what we have is something called Council of LLMs. So we have some high-end 2 to 3 models where we send the same prompt, same context, and try to see whichever is the answer. And there is an arbitrator LLM which will look at all 3 and then provide a verdict.
Okay, got it. So there is no straight away; it is continuous one solely.
Yeah, it is a continuous event.
Thank you. Keep on sending this up-to-date information also, so that we all make in sync. Okay.
Yeah. Sure.
Thank you.
And you are still having, I see a lot of Facebook Insta reels where you are singing. You still do that?
No, not that Sri Kumar Reddy. The other one.
Ah, okay. Yeah. Oh, sorry. You
Got
are
it,
SK.
right?
Yeah. You're not SK. Sorry.
Okay, man.
Yeah.
Okay.
Thanks, Sri.
Yeah.
Yeah.
Bye.
Bye. Okay, so that sums up. I think, yeah, it's 2 o'clock, and I think I have a hard cutoff now. But really, thanks to everyone who joined the session. I hope it was. The feedback that you gave really helped. I understood what you guys wanted, so we have just done some minor modifications. Hope the modifications went well. We will look into another use case in such details. Give a big round of applause to Kaivalya, Aditya, and Senthil. They are students of the IIT-MBS program. I think two of them are entrepreneurs by themselves. I think Senthil is working somewhere. So amidst all this, they spared their time for this session. Thanks, guys. Next week, we'll bring another set of team who will explain their Gen AI application. Okay. Yeah. Thank you, everyone.
Yeah. Thanks all.
Thank you.
Yeah, thanks, sir.
Kaivalya and others, can you update the slide deck also onto the GitHub repo? Is there anyone?
Yeah, sure.
Aditya, yeah, just add the slide deck under a docs folder. Okay.
Yeah.
Okay. Thanks, guys.
Thank you. Bye.
Bye.